Good morning, everyone. It's time for an insightful panel discussion on the topic Bridging Gaps in Mathematics Learning at Different Stages in School and Undergraduate Education. Today's discussion will explore how we can identify and address these gaps, create seamless learning experiences, and empower students with a deeper understanding of mathematics.
और इसकी शुरुआत करने के लिए मैं आमंत्रित करना चाहूंगी एक प्रेरणादायक व्यक्तित्व को जिन्होंने अपने क्षेत्र में अद्वितीय योगदान दिया है। तो टू स्टार्ट दिस डिस्कशन लेट अस ऑल वेलकम our chair and moderator Professor Inder K Rana sir among us. So please give a big round of applause for sir. He is an emeritus fellow at Department of Mathematics, IIT Bombay, Powai, Mumbai. He retired after a service of 33 years. He has been a visiting professor at Department of Mathematics from Ohio University. He has presented papers and delivered talks at many national and international conferences, such as the International Congress in Mathematics Education. He has guided PhD students and has published books such as Introduction to Measure and Integration, American Mathematical Society, Graduate Studies in Mathematics, and From Number to Analysis, published by World Scientific Press. He has received several awards such as C.L. Chandra Mathematics Award in year 2000 and Aryabhatta Award in year 2012 by the All India Ramanujan Math Club, India for teaching and work towards math education in India. He is the founder of the Technology and Innovation in Mathematics Education Conference and has been successfully organizing this conference since 2005. He is also the president of AMTI, that is Association for Mathematics Teachers in India. So please give a big round of applause for sir.
Before I put on my cap as the chair for session, I just want to say something which is displayed called Time 2025. This is a biennial conference held every 2 years in India. It's called Technology and Innovations in Math Education. Uh, this December, it is expected to take place somewhere in India. Which place, what is the venue? I have no idea. Uh, but if you want to know more later, send me email. I will keep your name in the my data of interested participants, and I'll keep on sending you emails about what is the progress regarding this. Mike, okay. I will. So there is an email of below ikrana at gmail. If you want to know more about it, please send me email as and convenient. I will mail details about this, whatever in progress. So that was something, the filler, okay, or self-introduction, whatever you want to call it. So let me, you can shut down the picture. That's okay. So let me come to the panel discussion of for today. Uh, Thank you very much for introducing me very nicely with the elaborate stars and so on. Uh, Today's panel discussion is on a very important topic called gaps in math education or math teaching and learning and what possibly can be done. It's a very difficult task, very difficult to identify the gaps in math teaching and learning and then how to fill those gaps. Uh, is something like the generation gap will always be there, my feeling. Like there is a gap between generations, same way the gaps in math education will stay because students are going to come, students are going to go, and so on. But we as educators, we as teachers should make effort to reduce the gaps as much as possible because there are two things. One, it helps the students if there are no gaps, and it helps the teachers to teach better, both ways. Otherwise, you keep filling the gaps and you don't know what one should do. So, With me, in the panel, we have got three panelists. Uh, One is Professor Amit Kulshreshtha. Uh, I don't know whether should we invite them to sit down because all are have presentations, so I don't know. Yes. Okay. So, and then there is Professor Anup Rajput, and we have Ms. Geeta Datta. So I will start with the way they are going to come and present. So Ms. Geeta Datta is a seasoned educator and for almost 30 years and with a vast teaching experience. Currently, she is as a PGT mathematics and supervisory head for DAV school, Sector 4 in Gurgaon. So she is integrating ICT in our teaching and learning programs. And I think let me not spend too much time on the. Please, I request Ms. Giti Adatta to come and give the presentation.
Very good morning to all the esteemed guests here. It is an honor to be a part of this August gathering. I don't have a presentation as such that everybody has a presentation. I just felt being a teacher, I have got this platform to talk heart to all my teachers and all my colleagues sitting here. Uh, the topic for today is bridging gaps in mathematics learning. Now, if I hope you won't mind if I interact with you also along with my session. Will that be okay? So, what do you understand by gaps in mathematics? Uh, Anyone who can tell me what do you mean by gaps in mathematics? Basics weak, okay. Some misconceptions, great. Procedural errors, missing prerequisite understanding, absolutely. Not getting proper. Okay. So basically, if I have to sum up what are gaps, I'll say that these are the areas wherein the student's understanding is deficient. You know, where the student is having some problem and he's finding a difficulty in progressing. Today being Basant Panchami, I think it's a very apt day to discuss such a valid point. Worshipping goddess Saraswati, goddess of wisdom, and what a nice day when we can, try to find out or reach to some conclusion that how can we narrow down these gaps or reduce these gaps. We can never finish it as sir said. ये gaps तो रहेंगे, generation gap है वो रहेगा, मैथमेटिक्स लर्निंग में गैप्स है वो रहेंगे, बट हाँ वी कैन ऑलवेज ट्राई टू गेट टुगेदर टू रिड्यूस दीज गैप्स. I am PGT Mathematics. I teach class 10 and I am a supervisory head for classes 6 to 8. So when I say the middle school, I have wide exposure to the problems the teachers and the students are facing these days. मैथमेटिक्स की टीचर्स मुझे लगता है बहुत मेहनत करती हैं. एंड ऑफ द ईयर वी हैव टू गो टू अ प्रिंसिपल एग्जाम्स के बाद में एक फाइल होती है जिसमें वी हैव डन द रिजल्ट एनालिसिस. Complete analysis is done for all the sections, for all the subjects, for all the teachers, and we take it to the principal, and she sees the qualitative performance index, the QPI of all the sections. And in last 20 years, I'm yet to go with my head held high कि मेरे मैथ्स के सब्जेक्ट की QPI शायद किसी एक सब्जेक्ट से भी ज्यादा. क्यों? We are working the maximum. I feel. I see my teachers, they're always struggling. They are working really hard. We are doing the maximum corrections. I should not be saying all the teachers are working very hard. English की एक नोटबुक बनती है पूरे साल की, साइंस की शायद 2 बन जाती है, सोशल साइंस की एक होती है, हमारी 5 to 6 notebooks plus assignments plus homework. So much correction we are doing. So much work we are doing, and still why not are we getting the maximum QPI? कहाँ problem है? Problem कहाँ है? एक phobia develop हो जाता है. Right from the beginning, some children inherit this phobia. Parents were always scared of mathematics, so the child automatically gets scared. पहली चीज ट्यूशन बच्चा कहाँ जाता है? मामा होम में करें, पापा जॉब कर रहे हैं, बाकी सब्जेक्ट्स में मैनेज कर लूंगी, मैथ्स नहीं होगा. तो द पुअर स्मॉल चाइल्ड इज गोइंग after school with a bag at his back and is going for the mathematics tuition. मैथमेटिक्स टीचर जो है, जो ट्यूटर है, वो बहुत अच्छी टीचर है, सब पढ़ा लेती है, मैथ्स में थोड़ा हाथ कमजोर है. Slight problem in mathematics. So the gap, the seeds of the gap are sown, I feel, there itself. That the teacher is not able to convey the things properly. A child is doing something else at school, something else the teacher is teaching and at tuitions, and the poor child gets a problem. The poor child is, gap starts building, and that gap keeps on increasing and increasing and increasing. मैथ्स का डर कैसा है? पीपल टॉक अबाउट मैथ्स, हाउ डू दे टॉक? दे से ही इज अ मैथ्स पर्सन, ही इज अ नॉन मैथ्स पर्सन, मैथमेटिक्स इज नॉट माय कप ऑफ टी. सम बच्चों से पूछो व्हाट इज द फुल फॉर्म ऑफ मैथ्स, एनीबॉडी कैन से, टेल मी. मेंटल mental assault on healthy students. My God, it was so bad to hear that. Then एक और, मेरी आत्मा हमेशा तुम्हें सताएगी हमेशा, कुछ ऐसा कुछ. मतलब आप देखो कि बच्चों को क्या क्या बातें, हाउ डू यू टेक मैथ्स. एक मैम हैड शोन द मीम टुडे इन द मॉर्निंग कि हॉरर सेक्शन में मैथ्स की बुक्स डाली हुई हैं. व्हाट इज दिस? इतना प्यारा सब्जेक्ट है हमारा, इतने शौक से हमने लिया है, वी आर सो पैशनेट टीचर्स, एंड स्टिल दैट फोबिया ऑफ मैथमेटिक्स वी आर इंक्रीजिंग एवरी सेकंड डे. कैसे, क्यों, कहाँ है प्रॉब्लम? जो गैप्स बढ़ते जा रहे हैं. I'd like to say something about Sir Ken Robinson, who said that mathematics is like a party to which many of us have not been invited, but some of us have not been invited. ऐसा है क्या? मुझे तो लगता है कि इट्स लाइक अ लैडर, और लैडर में जब एक एक गैप बढ़ता जाता है तो एक एक रंग उसका मिस होता जाता है. I am having a problem in class 5 mathematics concepts. I am pushed to class 6. 2 rungs of mathematics that are missing in class 5. Teacher has to teach class 6 syllabus. She will go on teaching class 6 because उसकी QPI भी उस पर डिपेंड करती है, उसका syllabus completion का भी. As ma'am said, Fauzi ma'am said कि sword of syllabus is always on our head. So that is also there. So what is the result? The 2 rungs which were missing in my ladder of mathematics, they become to 4 when I am going to class 6. Does it happen? होता है ना ऐसा? आई थिंक एवरीवन, आई कैन सी दैट एफर्मेशन कमिंग फ्रॉम ऑल द टीचर्स कि ऐसा ही होता है. छोटी सी मिस प्रॉब्लम थी, एक बच्चे को फ्रैक्शंस नहीं आते थे, फ्रैक्शंस नहीं आए तो व्हेन यू गो टू क्लास, सीनियर क्लास, यू आर नॉट एबल टू सॉल्व द क्वेश्चंस ऑफ रैशनल नंबर्स, you are not able to solve ratio proportion, you are not able to solve percentages, और रिजल्ट क्या होता है? 10 तक आते आते this is what I get, 2 plus 3 upon 9, 3 and 9 cancels and I am getting 2 upon 3. ऐसा होता है? Yes ना? तो ये एक बड़ी common problem है. कहाँ? क्योंकि fractions were not taught properly to me. I cannot cancel out this number. This is the numerator itself is whole. Fractions कैसे पढ़ाना है? This is numerator, this is denominator, part of a whole. Fractions शुरू हो गए, क्लास में questions शुरू हो गए. कहाँ? टाइम नहीं है हमारे पास. So we have to make that time, we have to change our teaching strategies so that we are able to get more time, so that we are able to interact more with the children, so that we are able to give some time to the students to take in. A teacher goes to the class, she starts writing the questions, children are copying the questions, one question after other we are giving them on platter the questions on the blackboard. Is that what we wanted to teach maths like? No, never. I never wanted to teach maths. I wanted to teach the concepts to them. I wanted them to practice themselves. I wanted to give them the questions wherein they'll come up with more questions and ask me. And मुझे परेशान करेंगे अच्छे क्वेश्चन से. वो नहीं हो रहा है, हो ही नहीं पा रहा है वो. जैसे तैसे बच्चा 6th में आया, मम्मी पापा को लगा ये तो मेरा IITian बच्चा है ना? और उसको कर दिया फिजी में, उसको एडमिशन दिलवा दिया। I have taken my child to the best of the institutes. He is going to Fiji. Fiji में वो इंजीनियरिंग की कोर्स कर रहा है। आप देखना मेरा बच्चा इंजीनियर बन के देखा। मैं नहीं बन पाया तो क्या हुआ? My child is going to become an engineer. होता है? Sixth onwards, imagine the mental level of the child who's studying something at school, something at home, something at his regular class 6 tuitions, and something different, very different in Fiji classes. So imagine the plight of the child. वो गैप जो थे वो 4 की जगह 6, वो जो रंग जो था इतना बड़ा हो जाता है कि बच्चा आगे जा ही नहीं पाता। क्लास 10 तक पहुंचते पहुंचते CBSE is really working hard. I was just talking to one of my senior teachers, HOD. She was saying कि problem कहाँ है कि gaps CBSE is rationalizing the syllabus day by day. Syllabus is reducing. Syllabus is reducing, and they are talking for average students. It's very good. But what we used to teach them 10 years back, वो concepts miss करते जा रहे हैं. यहाँ से this topic cut from this exercise. वो जो कुछ important चीजें थी, जो अच्छे questions थे, वो भी साथ में 10th में cut हो गए. She was telling about conic sections. Conic sections में general equation से आप कितना डिफरेंस आप आ जाता है। जो कुछ आप क्लास सीबीएसई में पढ़ा रहे हैं क्लास 10th में, डू यू थिंक जस्ट द ब्राइटेस्ट ऑफ द स्टूडेंट्स who's getting 9900 in CBSE will be able to do fantastically well in IIT also? No, JEE में नहीं कर पाता। क्यों? क्योंकि सिलेबस डिफरेंट है। दैट गैप इज देयर, सो दैट गैप नीड्स टू बी फिल्ड बाय ऑल ऑफ अस। कहीं ना कहीं वी ऑल नीड टू गेट टुगेदर एंड सी अ कॉमन प्लेटफॉर्म वेयर इन जो सीबीएसई का सिलेबस है, जो जेईई का सिलेबस है, वो कहीं एट पार हो। मे बी द डिफिकल्टी लेवल इंक्रीजेस, बट यस एटलीस्ट द सिलेबस शुड बी सेम। ऐसा नहीं होना चाहिए कि आप ए बी सी तक डी तक एफ जी तक पढ़ा रहे हैं सीबीएसई में और सीधा ही बिल्कुल कुछ और अलग चीज आपकी जेईई के लिए आ रही है। सो दैट शुड नॉट बी देयर। प्लस आप देखिए कि 10th क्लास में भी जब हम देखते हैं तो इवन वेरी स्मॉल मिस्टेक्स विच वी फील कि बच्चों को ये चीज आनी चाहिए थी, वो नहीं आती। आई वाज टॉकिंग टू सर जस्ट नाउ, ही वाज टेलिंग कि जब वो वहां आते हैं सीनियर क्लासेस में पढ़ने के लिए आते हैं तो भी जैसे तुम्हें ये भी नहीं सिखाया, तुम्हें ये भी नहीं आता, तो वो व्हाट इज दैट? दोस गैप्स हैव नॉट बीन फिल्ड, दोस गैप्स आर स्टिल देयर, दोस गैप्स आर नॉट रिड्यूसिंग। I just have few statistics, some data which I had taken out, and it is really alarming to see. The National Achievement Survey (NAS) conducted by Ministry of Education, it provides high insights into the learning outcomes across different grades. It states that only, mark it please, 45% of grade 3 students were able to perform at expected level in mathematics. Only 45%. Around 50% of grade 5 students performed below the grade level, and nearly 50% of grade 8 students failed to meet the expected levels of proficiency in mathematics. This is real data. This is not that I am talking kuch bhi bol, this is actual data. The annual status of education report ASER 22 survey conducted by Pratham showed that in rural India only 27.4% of the children in class 5 could solve class 2 level problems. 4th class का बच्चा 5th class का 2nd class के level के questions नहीं कर पा रहा। कितने सिर्फ कर पा रहे? Only 27.4. Around 46.2% of grade 3 levels could not perform basic subtraction. So कहीं तो झटका हम सबको लगना चाहिए कि कहाँ, where is the problem? How is it that the child is progressing to class 5, class 6, class 8 and not even basic subtraction he is able to perform? The COVID-19 COVID जो हुआ वो that was a big setback. कितना बच्चों ने lose किया at that time? COVID, this is the COVID batch we call them. This is the COVID batch. इनको नहीं समझ में आएगा. This is the COVID batch. This is how we talk. Because that time we were giving everything on platter. We had learned technology. We were the first, I feel, first time we were taking online classes. We did a lot. We have struggled a lot. Presentations every day बन रही हैं. Every day something or the other coming up. We have really worked hard. But do we have the same results from the students? No. So where they were not able to concentrate, they had their phones, they had their gadgets in hand. वो कहाँ का कहाँ लर्निंग जाती गई, कितने ड्रॉप आउट्स हुए, कितने स्कूल्स में तो बच्चों को दे कुड नॉट इवन go to the schools, they could go to the schools and they could not even have any access to the learning. So that was again a big setback. Then lastly, if you see, the India participated in TIPS 2019, the Trends in International Mathematics and Science Study, which stated that the Indian students lagged behind the international peers in mathematics for both grade 4th and 8th levels. So somewhere the problem is there and it's a great problem. But yes, it is solvable. It is not that it is not solvable. We can join hands and work together. एफर्ट हमारा तरफ से जाएगा, वो पैशन हमारी तरफ से होनी चाहिए. We can give them, there are certain things we can have: diagnostic assessments, targeted instructions, scaffold learning, visual aids and manipulatives, practice and reinforcement, real world connections, very important, how to relate mathematics to the real world, and collaboration, peer support. In our school, we have a very good program that runs a mentor-mentee program. What is that? Every teacher adopts two students from his class or her class, and she literally adopts them. And she goes through ki how what the child is learning, how the child is progressing, उसका result कैसा आ रहा है, is she working or not, उससे regular phone calls, basic parents से regular calls उसकी, exams में कितना सोया, कितना, तो that child is like her own child, and that is actually bringing a difference. So that resilience has to be with the teachers. It's a continuous process. We have to be patient. Nothing is impossible. Impossible itself says, I am possible. So let's together join hands and ensure that this effort of ours is successful and we are able to do something for our students. Thank you so much.
Please keep note of the important points Geetika has said, and we'll take up questions in the end when everybody is presented in the playlist. Then in the discussion, you can ask as many questions, and we'll love to hear more from the teachers on this topic. So I would like to invite the next panelist, Dr. Anup Kumar Rajput. He is from NCRT, and I think he has written so much in NCRT in various aspects of math education that is very difficult to sort of sum it up. Uh, I'll just say that presently he is Nodal Officer to Ministry of Human Resource and Development and working in reducing something which we all have been mentioning. Geeta also mentioned called math phobia. So he is one of the officers trying to tackle that phobia. Probably we'll learn more from him. Please.
Good morning to everyone. Respected chair and other participants of this 3 days conference, which is now going to be closed today. And it is my privilege of talking to you on one of very important issues, that is bridging the gaps. So it is essential that we should first understand what are the gaps. Some of them has already been talked about by Geetika ji, and my other colleagues will also speak about this. Probably many of them you may be knowing. I have divided these gaps and their region in three parts. So one are the curricular gaps, the curriculum which has been presented to children and to teachers certainly has gaps, wherein we must somewhere be taking these all in a very, very detailed manner and very seriously. When we say about the foundational stage, probably you may be knowing that national education policy has divided now the whole school education into four parts. One is the foundational stage, which is for the first 5 years, age 3 to age 7 or 8 years, and then second is the preparatory stage, which is for grade 3, 4, and 5, and then the middle stage for grade 6, 7, and 8, and secondary stage from grade 9 to grade 12. And in these all stages, the curriculum has been divided into parts and with a continuum and with a gradual shift from one stage to another. But that shift is really very, very difficult and is problematic. what we are doing in at foundational stage, why these first 3 years of school education have been taken into consideration when this national education policy has come up. We already had in some of the schools in our country these first 3 years of preschool education, which is from grade 3 years, sorry, age 3 years to age 5 years. We can say somewhere it was in a systematic manner with 3 years, somewhere it was in 2 years, somewhere it was in without any fixed duration in Anganwadis in the country, and this is going on, but everywhere the objective is different. When we say child is in Anganwadi center, the objective is to take care about the nutritional and health related issues of the child, and very less on the education and cognitive development. And when child enters grade 1, obviously there must be some gaps which are required, which child brings from the home. And when enters grade 1, there are some gaps, and these gaps are not being addressed. Then from foundational to preparatory, when we enter, obviously the curriculum talks about many things. I have written here, I'm not going to repeat whatever is written there. You can take a photograph of that, or otherwise these presentations are available to you. But this is very, very essential that we should understand what are the objectives of teaching, teaching and learning at these stages. The objective of at foundational stage is giving a strong foundation of literacy and numeracy. And when we say numeracy, we understand that numeracy is related to numbers, and we start talking about numbers when a child enters any center, maybe in a private school, where in KG, nursery, upper KG, UKG, and many other such nomenclature grades are being taken care. And we start child to, or otherwise we expect the child to start writing when child is entered in grade 3, or sorry, at age 3 years in any nursery or this. But what curriculum says, is it being addressed appropriately in the system? Not at all, because we understand that at age 3 year to 5 year, the fine motor skills are under development of a child. But these are not taken care. We start giving a pen in those delicate hands of a child, and we understand that child should start writing. And this understanding is passing on from parents to school, and school is doing what parents demand. So there is a bigger gap in this, because curricular expects something which teachers try to follow, system try to follow, and parents and society demand something. This is happening. A child, when a child is entered in a school or admitted in a school, parents demand or desire that my child will become doctor, my child will become engineer, my child will become this or that. But no one desires that my child will learn for life. My child will be having something which will make him a good human. No objective in our school education system is put in like this. Even in mathematics also. Many of us use mathematics, but maybe you all have learned mathematics up to class 10th. Everybody has studied mathematics. You all are from mathematics, studied, maybe have studied mathematics at higher levels also. But how many of us are using that mathematics which we have studied in our daily life? And if we are not using, where are the problems? So it is not the problem of the curriculum, we can say, but the problem of this transaction of the curriculum. How the curriculum is being transacted in the schools, how it is being taught, how it is implemented in the system. That is very, very important. And the major flaw lies with the teaching system, the schools, and the examination. I'm not saying that teachers are at fault or the schools are at fault, because obviously teachers and schools will do what society demands. And particularly in private schools, when a child is being admitted, then teachers have to take care of the parents also, and parent demand that my child should study whatever is being asked in examination. So the bigger culprit for everything is the examination system. We are not assessing skills, we are assessing only knowledge. We started talking about competency based education, we started talking about 21st century skills in 2005. But how many of us are implementing it in our system? How many of us are able to find out that if you are given an option of buy one get one free, and another shopkeeper offers you will get 50% discount whatever you buy, where will you go and why will you go? In which shop will you go and why? Do you take decisions on assessing which one is better for me? Do you apply whatever mathematics had been learned? So problem lies with my system. Whatever we are teaching, that obviously is very, very faulty. Next slide. So obviously the learning teaching material, whatever is being presented is particularly in mathematics, is focusing on providing repeated practice, understanding rules and formulae, not understanding, using those all rules and formulae, and considering that mathematics is made up of rules and formulae only, and applying those with repeated practice. And obviously when we write books in NCERT, for every stage, I started doing this in 1992, writing 10 CRT test students. Since then, we have written 3 generations of books. But whenever from for grade 6, 7, 8, 9, 10, up to grade 5, there are lesser problems. But from 6 onward, there are major problems when teachers say that इसमें ना हमें जितने क्वेश्चंस दिए उसके जैसे एग्जांपल जरूर होने चाहिए बुक में, क्योंकि जैसा क्वेश्चन है ना उसको वैसे तो सॉल्यूशन रेप्लिकेट करना है, और अगर नहीं दिया है तो देयर आर सम अदर पब्लिशर्स, वाटी शर्मा एंड अदर, जो आपको क्रैम कराने के लिए जोर दे रहे हैं। क्यों? क्योंकि एग्जाम में वो जरूरी है, आपको वही तो प्रॉब्लम सॉल्व करनी है, लाइफ की प्रॉब्लम तो सॉल्व करनी नहीं है। सो हमने कहीं फोकस छोड़ा, वो गैप वो है, वो हमें वो पकड़ के रखना चाहिए था। हमने कंस्ट्रक्टिव डेप्थ की बात नहीं की, हमने कहीं उन कॉम्पिटेंसीज की बात ही नहीं की जो मुझे मिलनी थी। कहाँ हमने क्रिटिकलिटी लेकर आए, कहाँ हमने वाई के बारे में सोचा। हम तो ऐसा एक्सेप्ट करते हैं, स्क्वायर रूट लेना है नंबर का और दो दो के पेयरिंग करनी है फ्रॉम राइट। क्यों करनी है पेयरिंग पता नहीं, बस करते हैं। हमने स्क्वायर रूट के लिए कुछ पर्टिकुलर एल्गोरिथम यूज करना है, क्यों करना है मुझे नहीं पता, बस लिखा है बुक में, मेरे टीचर ने बताया बुक में लिखा है इसलिए करना है, और आई एम एबल टू सॉल्व दीज प्रॉब्लम्स। प्रॉब्लम ना मुझे ये समझ नहीं आ रहा है कि हमें करना क्या चाहिए। हमें क्या, मेरा आज का पर्पज जो है वो मैं कभी इस गैदरिंग में भी औरों में भी सुनता हूं कि ना मैथमेटिक्स को पर्टिकुलरली मल्टीप्लिकेशन टेबल तो याद होने चाहिए, वो मुझे लाइफ में हेल्प करे। कहाँ हेल्प करेंगे? क्या मुझे आज के टाइम में जो मशीन्स मेरा काम कर दे रही हैं, तो इस ब्रेन को मुझे उस काम के लिए लगाना चाहिए जो मेरे लिए एक बेटर मशीन एक बेटर तरीके से कर सकती है। मुझे तो उस तरह से बच्चे को तैयार करना है जिससे बच्चा एक नई मशीन बना सके, एक नए एल्गोरिथम को डिराइव कर सके, और पूरा करिकुलम इसके ऊपर बात कर। सो प्रॉब्लम कहाँ लाई कर रही है? प्रॉब्लम है मेरे टीचिंग प्रोसेस में, प्रॉब्लम है मेरे एग्जामिनेशन में, और इससे ज्यादा बड़ी प्रॉब्लम है हमारे टीचर एजुकेशन प्रोग्राम्स में। मैं मानता हूं कि बीइंग टीचर हमें बहुत सारी लिमिटेशंस होंगी, रेस्ट्रिक्शंस होंगी, जहां मुझे सिस्टम को आगे बढ़ाने के लिए मुझे बच्चों को एग्जाम के लिए तैयार करना है, मुझे बहुत कुछ और भी करना। आई मीन स्पीकिंग इन हिंदी, कुछ को प्रॉब्लम तो नहीं है ना? अच्छा, सो मुझे ना बच्चों को एग्जाम के लिए तैयार कराना है, और वो सब करना है जो पेरेंट्स चाहते हैं। पर क्लास 8 तक तो ऐसी कोई मैंडेट है ही नहीं। क्यों क्लास 1 के बच्चों को मैं ग्रेड को जो 10th क्लास में बोर्ड का एग्जाम होना उसके लिए अभी से उस तरह के क्वेश्चंस के लिए तैयार करना शुरू कर दूं? क्यों ऐसे क्वेश्चंस के लिए तैयार नहीं करता जो वाई के ऊपर ज्यादा फोकस होते हैं इंस्टेड ऑफ व्हाट एंड हाउ? हम व्हाट एंड हाउ पर तो ज्यादा करते हैं ना, व्हाट आर फैक्ट्स, जो आज हैं कल दूसरे हो जाएंगे, बदल जाएंगे। जो किसी बुक में लिखे हुए हैं क्रैम करो, रिप्रोड्यूस कर दो, यहां नहीं है तो आज गूगल बाबा के ऊपर डालो, वो आपका आंसर दे देंगे। हाउ आर दी प्रोसेसेस? प्रोसेसिंग सारे के सारे मैथमेटिक्स के जितने प्रोसेसेस थे कॉमनली हमने उनको फिक्स कर दिया, हमने कहीं उनमें वो फ्लेक्सिबिलिटी नहीं रखी। तो हमें कहीं वो उसके ऊपर काम करने के, क्लास 8 तक आपके हाथ में है, जो हम पूरे स्कूल सिस्टम को उस पर कर लेना चाहिए। मीडियम ऑफ इंस्ट्रक्शन अपने आप में एक बड़ा इश्यू है। हमें लगता है कि इंग्लिश में पढ़ा देना चाहिए, लेकिन इंग्लिश में पढ़ाने के बावजूद मैं उन सो कॉल्ड प्राइवेट स्कूल्स की बात भी करता हूं। कितने बच्चे कंफर्टेबल होते हैं प्राइमरी तक सिर्फ उस मीडियम में पढ़ने के लिए जो जिसमें आप पढ़ा रहे हो। उनको डबल स्ट्रगल हो रहा है, लैंग्वेज का अलग स्ट्रगल है और वो जो कंसेप्चुअल अंडरस्टैंडिंग है वो अलग स्ट्रगल है। आप तो उनका स्ट्रगल बढ़ा रहे हो मीडियम इंस्ट्रक्शन को वो रखकर जो बच्चे का होम लैंग्वेज का मीडियम नहीं है, जो बच्चे की जो होम लैंग्वेज है जिसको मदर टंग बोलते हैं वो नहीं है। तो किसकी प्रॉब्लम है? ये तो फिर प्रॉब्लम हमारी है ना, हमने अगर वो रखा है। हम आज भी मीडियम ऑफ इंस्ट्रक्शन कहते हैं कि ये ना इंग्लिश है, बट पढ़ाते किस में? ग्रेड 1 के बच्चे को मिक्स्ड में। पेरेंट्स को लगता है कि बच्चा ना इंग्लिश में फ्लुएंटली बोलना शुरू कर दे, एज इफ इंग्लिश बोल देने से मैथमेटिक्स आ जाएगा। या साइंस में वो साइंटिफिक एटीट्यूड आ जाएगा, शायद, पता नहीं, वो पेरेंट्स को समझने की जरूरत है। इंग्लिश एज ए लैंग्वेज जरूर पढ़ाइए, मुझे कोई प्रॉब्लम नहीं है, आप 4 लैंग्वेज और पढ़ा दीजिए, लेकिन मीडियम ऑफ इंस्ट्रक्शन वो रखिए। हम कितना ही पॉलिसीज में बोलते हैं, बट हो नहीं रहा है क्योंकि सोसाइटी की डिमांड गड़बड़ है। हाई स्टेक बोर्ड एग्जामिनेशन है क्लास 12th में, आप क्लास 10th में बच्चे क्या पूरा कैरियर, पूरा फ्यूचर डिसाइड करना चाहते हो कि उसको साइंस में जाना है, कॉमर्स में जाना है, मेडिकल में जाना है, क्या करना है। और क्लास 12th के बाद तो इतना सारा वो है कि हायर एजुकेशन में होना है, प्रोफेशनल इंस्टीट्यूट में एडमिशन मिलना है, वो चाहे आईआईटी हो चाहे कोई और हो। तो हमने इतना हाई स्टेक एग्जामिनेशन रखा क्यों? क्यों नॉलेज को हम बेस नहीं बना रहे हैं? हमने जो किया, हमने सिर्फ इंफॉर्मेशन को रखा, और इंफॉर्मेशन ने ट्यूशंस को ज्यादा, कोचिंग इंस्टीट्यूट्स को ज्यादा प्रमोट किया। हम चाहे सीयूईटी की बात करें, जब तक सीयूईटी आया नहीं था तब बोर्ड के एग्जामिनेशन में थोड़ा, मैं जितने लोग प्राइवेट स्कूल से हैं वो सब समझते हैं, थोड़ा सा सीरियसनेस थी स्कूल में, क्योंकि मार्क्स की इंपॉर्टेंस थी थोड़ी बहुत। लेकिन अब तो बिल्कुल ही खत्म हो गई, बच्चे सीरियस ही नहीं है स्कूल में। क्यों? क्योंकि सीयूटी के लिए तो कोचिंग में होना है। हमारा ये सिस्टम तो मुझे तैयार ही नहीं कर रहा है स्कूल वाला। तो कहीं इसके ऊपर काम करने की जरूरत है। और क्लास 8 तक आपके पास है, इसको प्लीज क्लास 8 तक मत आने दीजिए। हमारे पास एक मेजर जो इशू है वो है टीचर्स प्रेपरेशन का। हम टीचर एजुकेशन प्रोग्राम में क्या करवा रहे हैं? क्या बीएड होना का मतलब है कुछ एग्जामिनेशन को पास करके और फिर आप में वो स्किल आ गई जिससे आप टीच कर लोगे? शायद नहीं। आपके पास वो टाइम, वो स्पेस आपको निकालना है, सिस्टम नहीं देगा आपको। आप कह रहे हैं कि ये जो सिलेबस या करिकुलम का तलवार आपके ऊपर लटका हुआ है, तो ये किसने बनाया है तलवार? ये मैंने मैंने 8 क्लास ग्रेड 8 तक हम टिम्स से रिलेटेड क्वेश्चंस, उस तरह की प्रॉब्लम्स को क्यों नहीं पूछते? टिम्स की बात की थी किसी ने, हमने वी नेवर पार्टिसिपेटेड इन टिम्स, वी पार्टिसिपेटेड वंस इन पीसा, प्रोग्राम इंटरनेशनल स्टूडेंट असेसमेंट। उसमें परफॉर्मेंस बड़ी खराब थी, उसके बाद हमने छोड़ दिया। हम क्यों इन इंटरनेशनल स्टैंडर्ड्स के ऊपर काम नहीं कर रहे हैं? करना चाहिए। टिम्स है ट्रेंड्स इन इंटरनेशनल मैथमेटिक्स एंड साइंस स्टडीज, आप इसकी वेबसाइट पर जाइए, आपको बहुत सारी प्रॉब्लम्स मिलेंगी। एक सिंपल प्रॉब्लम है, ग्रेड 4 के बच्चे से पूछी गई थी, नंबर ऑफ व्हाट इज द नंबर ऑफ टेंस इन 273, नंबर ऑफ टेंस इन 273, एंड एक्सपेक्टेडली जो हमारा आंसर होना चाहिए था, लोगों ने, जो मेजोरिटी ने आंसर दिया, दैट वाज 7, जो रॉन्ग है। तो क्यों हुआ ऐसा? क्योंकि हम कर ही नहीं रहे तैयारी ऐसी बच्चों की। और ये टिम्स का क्वेश्चन है, और ऐसी बहुत सारे क्वेश्चंस आपको कहीं ना कहीं मिलेंगे। सो काइंडली उनको बेस बनाइए। ये ग्रेड 4 पर, ग्रेड 8 पर आपको इसकी बहुत सारी प्रॉब्लम्स मिलती हैं। पीसा से रिलेटेड प्रॉब्लम्स को थोड़ा परकोलेट नीचे की तरफ को कराइए, वो गोल्स करिए। हम उनसे बहुत दूर जा रहे हैं। हाँ, पेडागोजी रिलेटेड मैंने अभी बात की थी कि हम ना, हमारा क्लासरूम पूरे का पूरा गड़बड़ वाला है। हमें उस क्लासरूम को वी हैव टू समवेयर अमेंड दैट क्लासरूम। आई मैं आपको एक फार्मूला बताता हूँ, टीचर्स हैं वो, और जो टीचर एजुकेटर्स हैं वो भी। आप ना एक 35 मिनट 40 मिनट्स के पीरियड में 30 मिनट्स वो करिए जो आपको लगता है कि ये सिस्टम की डिमांड है, ये मुझे तो करना ही पड़ेगा, मेरा मन नहीं करता फिर भी मुझे तो करना ही है, मुझे वो कराना है जो बुक में लिखा है, जो एग्जाम के लिए सेट कर दो 30 मिनट्स तक। 5 मिनट्स और 10 मिनट्स के लिए वो करो जो हम अभी बात कर रहे हैं, वो करो जिसमें बच्चे को मजा आता है, जिसमें डॉक्टर फौजिया ने कितना इंपॉर्टेंटली बोला, कितना अच्छा टूल है वो हर बच्चे में एक इंटरेस्ट क्रिएट करने के लिए। वो मैथमेटिक्स को एग्जाम में पूछे जाने वाले क्वेश्चंस का सेट ना माने, वो समझेगी कि लाइफ का बड़ा इंपॉर्टेंट आउटपुट, कितना मजा है इसमें। क्यों वो आर्ट्स और म्यूजिक में ऐसा नहीं करता, मतलब ऐसा करता है, और मैथमेटिक्स में ऐसा नहीं करता, इतना एंजॉय नहीं करता। जो कहा था कि वो जो हॉरर वाले जो वो है उसमें लिख दिया मैथमेटिक्स को कि बहुत टेरिफाइंग है और बहुत प्रॉब्लमेटिक है, मुझे तो बहुत डर लगता है। और ये शायद डर फाउंडेशनल स्टेट के ऊपर शुरू हो जाता है जब बच्चा ग्रेड 3 में आता है, और विजिबल होने लगता है जब बच्चा ग्रेड 6 में आता है, और तब विड्रावल सिंड्रोम होने लग जाता है कि मेरा कब जान छूटे इससे और कब मैं इसको छोड़ूं। तो कहीं हमें इसके ऊपर काम करने की जरूरत है। हमें ये जो ट्रांजिशन है कॉग्निटिव स्टेजेस का, इसको स्मूथ बनाना है। फाउंडेशनल से बहुत काम फाउंडेशनल पे करना है। पॉलिसी ने इसके ऊपर बात की है, आप इसको थोड़ा और प्रैक्टिस में लेकर आएंगे और इसके ऊपर ज्यादा काम करेंगे। पेरेंट्स, सोसाइटी की एजुकेशन उतनी ही इंपॉर्टेंट है। मुझे लगता है कि उनका एक बड़ा इंपॉर्टेंट रोल है इस पूरे सब्जेक्ट को वैसा बना देने के लिए। जैसा हमें आज दिखाई देता है। उसमें अगर पेरेंट्स अपना रोल प्ले करें, सोसाइटी अपना रोल इम्पोर्टेंटली प्ले करे, तो शायद ये इसको हम इम्प्रूव कर सकते हैं। थैंक यू वेरी मच फॉर प्रोवाइडिंग दिस अपॉर्चुनिटी।
Thank you, Anup. I think you have touched almost every aspect of the gap. Uh, of course, there are gaps, but still we need to think about how to fill those gaps. I think we have not thought about such things. So there will be discussion on that also, hopefully. That's why that is more important. I think almost every one of us knows that there are gaps, but what could be possible way of doing some remedial of at least making gaps a bit smaller rather than that big gaps and becoming bigger. So we'll do that in discussion time. Next panelist, I would like to invite my friend Amit Kurseshra. He is from Mysore, Mohali, and I think let me not say more about him because he's done a lot of research papers. He is PhD from Data Institute of Fundamental Research. And it's nice to see that mathematicians from higher education are interested in math education. This is a very rare phenomenon that people want to, in higher mathematics, people want to publish papers, do research from assistant to become associate, assistant to professor, professor to up, so on by publishing papers. But very few are concerned with the state of mathematics, how we will get good students, and the problem lies at the bottom. So, guys, please. Yeah.
Thank you so much for inviting me here. It's a pleasure. What I will say here, I think I will just try to echo whatever you already have. And these are observations from someone who is not deep into education, but has been observing education and seeing the output of the school system. So I am from Aisar Mohali, and we receive students after they have finished their graduation, after they finish their class 12th, and they have passed some big competitive exam, right? So these are the students who at the school level may not be recognized as gap holders, but we start seeing certain gaps, and I'll talk about that. Uh, since I'm from the last end of the academic trajectory, right, and I'm from the higher education side, so I will see gaps at various levels at the level of primary education, secondary education, and even undergraduate. Uh, there are a couple of points which are irrelevant of which level of gap we are talking about. One very important thing that we have to understand is what is the source of the gap. Source could be of various types, and some of them could be superficial, and some of them could be very serious to feel, but still we should be sensitive enough about existence of those gaps. I just try to understand for myself how can I classify gaps. For source of gaps, one is curricular gap in the curriculum, and sometimes rationalization happens, sometimes books change, sometimes certain schools will put certain publishers' book and then certain other publishers' book will come. All those I just categorize into curricular kind of gap. Uh, those may be local, meaning to a certain part of country, those gaps prevail more than other. But anyway, those exist, we acknowledge, and I feel it's possible to fill those gaps. They're fillable if there is enough brainstorming and we come up with various threads in the curriculum. Okay, this is not really required to have a uniform curriculum all through, but certain threads you can identify, you can pick, and you can create things which are consistent, at least which motivate child to perceive maths. So I think curricular gaps one can work on. Other gap is more serious, which I call social gap. I mean, gap because of society, the gaps which have source in society. And I keep three parts of the society. Child is anyway there, so I'm not keeping the child in that because child is the one which is our main focus. So I'm not blaming child for creating any gap. Child is sufferer after all. So three parts of society which I'm categorizing here are PTM. Parents, they have expectations from child. It's not clear to us right now what does society expect from mathematics. In fact, it is not clear what does society expect from education. It's not clear even for education. That's a much bigger question. Mathematics का तो फिर बाद में ही है. I think the society, the expectations of the society and that they're essentially parents. So collection of parents is society for this purpose, right? Are driven by the third part. So P for parents, T for teachers. Teachers are part of the problem and solution both. I'll just explain. Don't get offended because that's a problem. And third is M. M is market. Market, right? Because market is providing certain types of expectations in the minds of parents. And who is supposed to fulfill all the aspirations? Poor teachers. Now, some of the teachers they resist, some of the teachers are not able to. And I can speak on those aspects, but maybe not much. Maybe the discussion part will take up. But when I say society, the source, the original source of the gap is market. I don't know how to address that. So this is society which is creating certain gaps, and those are really, really difficult to fill. So I have no courage to speak on that. But something which we can uh, talk about, those gaps I classify as so curricular gaps were there, social gaps were there. Third one is for me linguistic gaps. And when I say linguistics, it's not about choice of language. It's not. Even a child nowadays is not able to express himself or herself in a mother tongue. इशू ये होता है कि जब बच्चा 7वीं 8वीं क्लास में आता है हम उसको बोलते हैं बेटा साइंस पढ़ मैथ पढ़ अंग्रेजी हिंदी कोई बात नहीं एक हफ्ते में हो जाएगा पतली वाली कुंजी आती है उसमें सब कहानियां कथाएं लिखी हुई हैं 9वीं 10वीं में तो हिंदी इंग्लिश पढ़ना ही नहीं है point is when child reaches that age क्लास 8वीं 9वीं बच्चे की जिस तरह से ग्रोथ होती है संसार को समझने की जो क्यूरियोसिटी होती है वो बहुत डिफरेंट है नए क्वेश्चंस हैं उसकी सोच में गहराई आने वाली है उस गहराई में जो सवाल है क्यूरियोसिटीज हैं उनको समझने के लिए बच्चे को लैंग्वेज के डीपर स्ट्रक्चर की जरूरत है एंड दैट हैज नथिंग टू डू विद चॉइस ऑफ लैंग्वेज जो डीपर स्ट्रक्चर जहां पे वो अपनी क्यूरियोसिटीज को एक्सप्रेस कर पाए जो सिमिलर लुकिंग सेंटेंसेस में डिस्टिंक्शन कर पाए वो तो हम नहीं दे पा रहे हैं क्यों क्योंकि हिंदी अंग्रेजी पढ़नी नहीं है राइट तो जो लिंग्विस्टिक गैप इस वजह से आ रहे हैं क्योंकि गहराई बच्चे को सोच में नहीं मिल पा रही है भाषा के माध्यम से है ना और गणित तो वही है क्योंकि गणित में एक जैसे सेंटेंसेस लगते हैं दिखने में लेकिन होते अलग हैं राइट क्योंकि सेम वर्ड्स की जंबलिंग है so that is a gap which I think we as educators can fill at all levels at every level for that I'll request the slides so I made some slides just assimilating my ideas and how to fill those gaps so here I am talking about gaps which are not market related, which are not curricular, but linguistic gap. Okay, so maybe again, since I said we have to understand source, so we have to go somewhat into philosophy part and then realize, oh, here is a solution. The teaching is happening this way. I have divided this slide into two parts. One is what I say, how the knowledge is constructed and how do we transmit that knowledge in the classroom or at other platforms. How is the knowledge constructed? For me, it's just my imagination. Every knowledge has a source in experience. You experience something, there's some experience. And then you try to convert that into a thought. And the thought comes, language comes, right? Language may have many parts. It could be a script, it could be a picture, it could be oral, but everything is starting from experience. And when you have similar kind of experiences, lot of time, you are developing a language, right? That we agree. Next, please. Huh. And when you are thinking about similar kind of things quite often, you start developing subject-specific language. Mathematics is one such. We develop lot and lot of subject-specific language. When I'm writing equation, subject-specific language, right? When I'm writing a logical sentence, if this, then this, provided that, that is subject-specific language. So we keep creating that subject-specific language, lot of that. That's there in the books. Next, please. And when you assimilate everything, all the concepts in subject-specific language, that is what is called subject, which is true for any subject, not just maths. Next, please. Now, when we are teaching in the classroom, what is happening? Uh, the teacher focusing only on the subject-specific language. Teacher is focusing only on subject-specific language, meaning in the classroom, we are just showing equations or pictures और इंटीग्रेशन का साइन दिखा दिया. साइकिल पूरी कैसे होती नॉलेज की? जब हम लर्नर को एक्सपीरियंस तक ले जाते हैं. वो तो हुआ नहीं, क्योंकि एक्सपीरियंस तक ले जाने के लिए हमको वो सब बातें करनी होंगी जहां से नॉलेज कंस्ट्रक्ट हुई है, वो हमने बात नहीं करी. हमने सब्जेक्ट स्पेसिफिक लैंग्वेज में बच्चे को अटका दिया, और सब्जेक्ट स्पेसिफिक लैंग्वेज और जो बाकी का लैंग्वेज का पार्ट है वो हमने गैप क्रिएट किया. दैट्स अ गैप, दैट्स अ सीरियस गैप, राइट? And that this particular gap, there is incarnation of this gap in like so many occasions. क्लासरूम में अगर हम कहें, इवन एग्जाम्स जो कॉम्पिटिटिव एग्जाम्स में इसका गैप दिखता है. Unfortunately, market has actually found a way to just focus on subject-specific language and get the child ahead in the perception of society and parents. टिक करूंगी प्रोग्रेस इंटीग्रेशन लगाया, काम हो गया, राइट? तो बिना एक्सपीरियंस, सॉरी, सो okay, so the point is, without taking the child to the experience, it's possible for the market to crack it, but that is not in the interests of our learning process. Certainly not. So at least as teacher, what we can do is that जो subject specific language और जो हमारी natural language है, कुछ भी हो सकती है, हिंदी, अंग्रेजी, पंजाबी, हरियाणवी एक्सेंट में भी हो सकता है, कुछ भी, नो प्रॉब्लम, ओके. बट हम अगर उसको गैप को फिल करने की कोशिश करें तो काम हो जाएगा. I'll just give you an example. I actually did some experiments in my classroom, which is not supposed to have so many experiments क्योंकि बड़ी क्लास है, कोई बात नहीं. So what I have been doing is, आज इस हफ्ते जो पढ़ाई कराई हमने, आप उसकी आधी पेज की समरी लिख के दो, लेकिन उसमें आप सिंपल कुछ यूज नहीं करोगे. डोंट यूज. आपको अंग्रेजी में लिखनी है अंग्रेजी में लिख दो, हिंदी में लिखनी है हिंदी में लिख दो. You give half page summary without using any dependence on subject specific language, because subject specific language is part of packaging of knowledge. It's not the core part. Core part is something else. Core parts are concepts, not notation. So without getting into that subject specific notational language, without getting into that particular notation, you just write in the language you are comfortable with. कि आपने सीखा क्या, क्या कोर था, क्या कहानी थी इस चीज की, वो आपको बताना चाहिए. लेकिन ऐसा होता तो नहीं है स्कूल में या फिर बाद में भी, क्योंकि जो सारी की सारी चीज गणित में हो रही है वो सिंबॉलिक मैनिपुलेशन हो रहा है. दैट इज जहां पे हमने बच्चे को अटका दिया है सब्जेक्ट स्पेसिफिक लैंग्वेज में, दैट इज सिंबॉलिक मैनिपुलेशन वाली बात करवा दी हमने, क्योंकि हम उसको एक्सपीरियंस तक तो लेके ही नहीं जा पा रहे ना, क्योंकि भाषा की बात हमने गायब कर दी. सो दिस इश्यू आई जस्ट वांटेड टू हाईलाइट, एंड देयर इज अ वे टू डू दैट एट एनी लेवल. आप अपने बच्चे को बोलिए, 8वीं क्लास का बच्चा है, कि आधा पेज लिख के बताओ अपनी भाषा में कि आपने सीखा क्या. तो बच्चा खुद प्रेरित होगा वहां तक उस अनुभव तक पहुंचने के लिए जहां से नॉलेज कंस्ट्रक्ट हुई है। तो बच्चे का एफर्ट भी आएगा और देन इट्स अ फैंटास्टिक फीडबैक फॉर यू। So this something which can be experimented at any level. And that is another thing which I do. Unseen passages usually अंग्रेजी हिंदी में होते हैं ना, रीडिंग कॉम्प्रिहेंशन और अनसीन पैसेजेस। हम लोग गणित में भी अनसीन पैसेजेस दें, जिससे जो हमने बच्चे को देखा कि इतना इसको समझ में आया है, कुछ अनसीन पैसेजेस हमने दिए, जो उसमें नया कॉन्सेप्ट हमने बच्चे को दिया, और फिर हम देखें कि बच्चा कैसे डेवलप करता है अपनी समझ को भाषा के माध्यम से। तो हमें भाषा को पीछे कभी नहीं छोड़ना है, लेकिन गणित वाले भाषा को हमेशा पीछे छोड़। This is something for which I'll sensitize teachers. कि you try to give some reading comprehensions in your exams or just in general conversations. These are examples from my classroom. Yeah, next thing also you can do. So this is a very common thing, ask students to make various word problems. I had to write one article in Pathshala. Pathshala is a magazine from Azim Premji University. I had written it. Uh, it was about the kind of language which is used in the classroom. The name I gave was इबारती सवालों की भाषा का सवाल। क्योंकि कई बार क्लासरूम में जो भाषा का इस्तेमाल होता है, या फिर जो क्वेश्चंस टीचर्स बना रहे होते हैं, तो प्रिसिशन नहीं होता है। प्रिसिशन इज अवर यूएसपी। मैथ्स का जो यूएसपी है, यूनिक सेलिंग पॉइंट, वही है कि हमारे पास प्रिसिशन है। अगर मैथ्स क्लासरूम में प्रिसिशन नहीं होगा तो गड़बड़ हो जाएगी, एम्बिगिटी नहीं होनी चाहिए। सो उस पे वन कैन talk about. So this is advertisement for my article, but it carries some points which are applicable for various levels. You can put one more slide, perhaps it's there. And that is another thing. कई बार चीजें मुश्किल हो जाती हैं बच्चों के लिए। आप बच्चों को बोलिए कुछ कॉन्सेप्ट देके, 12, 13, 14 साल का बच्चा है, कि अच्छा आपको ये समझ में आ गया, आप अपने से छोटे बच्चे को कैसे क्या चीज पढ़ाओगे? तो फिर उसमें बच्चा खुद से गैप फिल करने की कोशिश करता है। 13 साल का होगा, उसको नहीं आ रहा, लेकिन जब आपने उसको जिम्मेदारी दी है कि आप छोटे वाले बच्चे को कैसे पढ़ाओगे, कैसे 10 साल के बच्चे के साथ इंटरेक्ट करोगे, तो वो 13 साल से 10 साल के बीच में जो भी अगर उसके दिमाग में गैप्स क्रिएट होते हैं, उसको खुद से फिल करने की कोशिश करता है। सो आई थिंक एज टीचर्स वी हैव टू बी कैटलिस्ट्स, क्योंकि हम लोग we cannot be part of the reaction, but we have to be catalyst. So these are some of the ideas which I think which can help us catalyze things. Last 2 points I'll make before I stop. One, which Professor Fauziya said in the morning, is a fantastic thing. I don't think she explicitly said, but that's what I could gather. We have to create events in the life of child. उन्होंने events बताया ना, कुछ नीचे पाइथागोरस थ्योरम दिखी उनको। हाँ, तो कुछ इवेंट्स होने चाहिए क्लास में। इवेंट्स मतलब टीचर जब क्लास से बाहर जाए तो उसको ये लगे कि आज की क्लास में क्या ऐसा कोई इवेंट हुआ है कि जो 10 साल बाद कोई बच्चा याद रखेगा कि ऐसा हुआ था क्लास में, इस वजह से मुझे अच्छा लगा। सो वी हैव टू गिव एनफ अपॉर्चुनिटीज फॉर द स्टूडेंट्स। तो उसके लिए हमें इवेंट्स क्रिएट करने होंगे और साइलेंटली करने होंगे। ऐसा नहीं कि बच्चों आज हम एक इवेंट क्रिएट करने जा रहे हैं, ऐसे तो नहीं हो पाएगा ना। वी हैव टू नेचुरली क्रिएट सर्टेन इवेंट्स इन द क्लासरूम silently. So that is one point. And in the end, I will say, like, not all gaps are bad. There are good bacteria, bad gaps, good gaps. There are some good gaps also. Some gaps could be our pedagogical strategies. दिमाग में कीड़ा छोड़ दो बच्चे के, सोचता रहेगा. But you have to very carefully plant those gaps as pedagogical strategies. Be aware about that, and those are good gaps, and let's be happy with that as well. So with this, I just wanted to throw some points so that we are ready for more stimulating discussion. Thank you.
So thank you, Amit, for your suggestions, and we'll debate about those also. So I think time has come to open the stage for questions and answers, which are more important because each of the panelists have tried to represent their uh, viewpoint or their experiences about the gaps possibly. So I would request the panelists to please come on stage so that we can मैं पंडित गिरी कर रहा हूँ. Yeah. So let me just summarize in 1 or 2 minutes what has been done in the panel discussion. Geetika talked about mostly about school level experiences, and main crux of her points was there is so much of time taken in writing and doing other than teaching, doing other things, that there is very little time left for doing something. Even those 5 minutes which Amit said that probably we should do every classroom as 5 minutes are not possible probably. Once you are doing probably 4 or 5 notebooks and corrections, right? I think Anup has talked a lot about all aspects of gaps and everything. Uh, so it's very difficult to summarize, but he has touched. There is math formula, there is math curriculum, and I think one of the things which I gathered from his uh, presentation was that we do all these committees and NCF and NEP and so on, but when we transact them to the classroom, they don't really transact to the classroom. They remain as policies to be transacted by somebody. I don't know who is that somebody will do it. Will it be the government bodies? Will it be teachers themselves trying to understand NEP first of all, and then trying to implement that also along with the teaching and learning? I think this is a huge responsibility we are leaving. It is something similar to uh, all state boards or probably central agencies. They write new books, and session starts in July, and the new book appears on August in the hands of teacher. And there is no method of training the teachers on how this new curriculum is going to be transacted. I think that also is a big issue. Before you are introducing something new, if there is a e-cycle coming in the market, probably you should tell customers how is e-cycle going to be charged, how is it going to be used, what is going to be the maintenance of this, what is going to be the benefits of this, and such things. There is never planned. Because, as I said yesterday, somebody is making a policy, NEP, somebody is doing curriculum, that is a separate body, no connection between the two. Somebody else is writing books for them. As Anup himself has said, being in NCRT, he is finding it difficult to implement something in the writing of books. And then transacting those books in the classroom, that is another issue. There is no mechanism for training teachers on that kind of thing. Teacher training, we had that. So I think I won't take more time. Let us try to hear your doubts, and possibly we or all of you can suggest possible solutions on mitigating these gaps. So I leave the platform open. Is it okay, Panelis? Right. So please, anybody would like to ask any question to particular panelists or to in general, please go ahead and raise hand. Mics will be passed on. Uh, एक मिनट ले लो जो क्वेश्चंस के लिए हो. Please just raise a hand. We will understand that you want a mic. Yeah. Please say you are from which level, school, college, or university. What's the nation? I'm not saying that you should only questions. You can have comments and suggestions also. You can welcome. All are welcome. Good morning. Good morning, sir. Here is something that I want to say to everybody. I learned it from somebody. Handheld mic, there is no way of speaking it. How do you speak? As if you're eating a banana. Hello, hello, as if you're eating a banana and then speak. That is the way I learned it from somebody. So I thought I will pass it on.
मेरा क्वेश्चन अनूप सर से है
Ah,
इवन दो आई एम नॉट टीचिंग इन क्लास 1 and 2 but the question is regarding class 1 and 2 being a faculty member we are as a team we are working so my question is to Anup sir कि class 1 और 2 में sir ये मेरी observation है मेरी faculty की observation है कि reading question comprehending the statement and converting it to mathematical scenario facing a lot of problem and NEP 2020 का जो objective था कि robust numeracy and लैंग्वेज, वो ऐसा नहीं है उसका रिफ्लेक्शन प्राइवेट स्कूल्स पर नहीं है, उन पर भी है। हो सकता है रेशो थोड़ा कम हो, बट ऑफ कोर्स है। तो इस चीज में टीचर ऑफ कोर्स इम्पोर्टेंट रोल प्ले कर रहे हैं, और पेरेंट्स का भी बहुत इम्पोर्टेंट रोल है एट फाउंडेशन स्टेज। बट पेरेंट्स इतने बिजी हैं आज के डेज में, डोंट हैव टाइम फॉर देयर किड्स, इट्स अ जनरल ऑब्जर्वेशन। तो हम इस गैप को कैसे फिल करें, दैट इज माय क्वेश्चन। So actually, we have to understand that the system has already mentioned it. We are not saying numeracy or literacy in isolation. We are saying foundational literacy and numeracy, FLN, has been introduced with this understanding that language is an important aspect of teaching learning of mathematics. And we nowhere say that we should talk about the symbolic learning, learning of symbols and operations and everything first, and then go for the word problems. This is a wrong premise. We should start with the word problems. Why can't we start with the child's context? So the system says that we should start talking about child's context. We used to adopt, uh, we propagate this, the philosophy of teaching. One of them is ELPS. E means experiences, L means language, P means pictorial presentation, and S means symbolic. This is the sequence which we should. And so first is the experiences with concrete material to be given to the children, whatever we are teaching, may it be the shapes, may it be numbers, may it be number operations, anything. So first we should give the experiences to the child. These experiences may be from home, maybe in the school, or maybe a linkage between these two, home and school. The second is the development of language. Language about that. So child should be given opportunities to talk about that. And that has been, I will mention that also with NE, NEP, and NCSE. And then third one is pictorial presentation of whatever is being taught. And last one is symbolic. But what we do, we start with the symbol, we start with adding up 4 and 5. But how 4 and 5 is coming in my life? We are starting with 4 apples and 5 apples, how many are total? And obviously, child will then translate it into language, and then will ultimately come up with he had 9 apples in the basket, not only 9, but with the context. So we start with symbol, and another basic problem is that first two parts, experiences and language, are to be taken care by the teacher. My book, whatever material is being given to the teachers and the students, start with pictures only. No, that can have only print, pictures and then symbols. So this bridging of ELPS, right from experience to language to pictorial presentation and then to symbolic, is to be followed. And if we are following this, obviously, this is the process which we should take care. Secondly, the national curriculum framework at foundational study very clearly mentioned about 4 block approach. And this 4 block approach, the first block is math talk. So we should talk about mathematics, whatever we are teaching. We should have a discussion among the children, maybe a very young child of age 4 years. We should start talking to the child about the text, about the content which we are going to teach, which we are going to discuss. This may be in the form of a story, maybe in the form of a poem, maybe in the form of a discussion or child's experiences, and so on. And then after that is skill teaching. We should start talking about the skills of those content, those concepts. Then third one is skill practice. And by practice, we mean repeated practice, which I once again emphasize, it should be practice in different contexts. First in familiar context and later in unfamiliar context. But we talk only about familiar context. Even then our children are not very comfortable. Familiar means whatever is given in the book is being asked. But if it is not given in the book, but is related, and then question is being asked, then how child is performing there. So we have to ultimately take care. So this skill practice, and last one is math games. Lot of games, lot of toys should be provided to the children. There must be some logical games which must be played with the children, providing opportunity to them. So if it is followed, obviously, then this all fear and everything will be gone. And uh, as I worked with Ministry of Education on reducing the fear of mathematics, and we came to the conclusion that if these are the first 8 years of schooling up to grade 5, that we are creating phobia of mathematics, fear of mathematics, or
the interest in mathematics or love to mathematics happens to grade 3. After that, whatever has been done can only be improved a bit, but we cannot redo it. So therefore, it is better that we should be more focused in the foundation and preparatory stage, inculcating the interest among children and following this. So I think I have given your answer. I just want to add something to that. Yeah, teach them symbols, counting. There's no counting actually. In class one, we can count up to 20 easily. That's a great thing for us because what we can do is rather than the conducting organizing games, just put them in an ambience which facilitates use of those numbers. Every primary classroom should have a weighing scale. It should have a measuring tape. It should have something with which you can measure the volume. Those measuring cans, small ones. That's all. Keep them there. Because if you don't do anything with that, child will find how to use them and how to connect that with numbers. Just yeah. Beyond that, उसका height, उसका वॉल्यूम आज हमने 100 ग्राम का एप्पल खाया है, 100 बहुत बड़ा नंबर होता है, 100 खाया है, आज मैंने एक भी खाया है. It's a great thing in a child. So create such kind of things on day-to-day basis. We facilitate that just by putting those things. I think I agree with, I mean, I remember one experiment done by something which is similar to a hole in the wall, but it was at the primary level kind of a thing, where in a room, cards of different colors, right? There are 50 cards are there of various colors, and no instruction, nothing to be done. And the kids are pushed into that room and quick wrote them. And after about half an hour, they found all orange cards separate, all blue cards separate. They have done something, matching of colors and everything themselves without telling. So she will have, and then probably Ruchi afterwards, because she raised her hand so clearly.
I actually don't want to, ask any
Please,
separate question, but just I wanted to, add on something to what has been already discussed.
yeah.
Uh,
Introduce always something so that your name or school or college or
I'm Vaishali Saluja. I am from Lotus Valley International School, Gurugram.
okay.
Uh, this is the biggest mistake that we as teachers have been making over the years, that we've been calling these comprehension-based problems as word problems. I think we could have given a better name to it, because when we as teachers announce this as a problem, the child is scared at the first instance. So rather than calling them word problems, can't we call them number stories? Can't we give a more better name? Story sums, yes. Sums again, then as a child, you would think that we need to give a solution to it. But when we talk of number stories, every child from the very childhood is more interested in listening to stories, in making stories, in reiterating them, in telling those that
Yeah,
story.
we understand. I think you start doing it so that everybody does it. She says they also do it. See, nobody has said to you that these are word problems. Where is it? The book doesn't say it's word problems. It doesn't say. Only you say it as teacher.
That's what I said.
Right.
We as
So
teachers have been using a wrong word for
okay.
that
So
introduction of that kind
your
of
suggestion is welcome. I think most of the teachers should have implement that problem.
Thank you so much.
Yeah. Ruchi,
मेरा इससे कनेक्टेड ही है
हाँ,
काफी.
please.
तो अमित जी, आपने जो शेयर किया कि अंडर ग्रेजुएट लेवल पे भी जो स्टूडेंट्स हैं उनको आप लिखने के लिए बोलते हैं. एक तो मैथमेटिक्स के बारे में जो परसेप्शन है लोगों का कि मैथमेटिक्स करना मतलब सिर्फ सिंबल्स के साथ करना, उसी को मैथमेटिक्स कहा जाता है. उस परसेप्शन को शायद हमें तोड़ने की जरूरत है कि मैथमेटिक्स में भाषा का बहुत जरूरी काम है. और इवन हायर लेवल अंडर ग्रेजुएट लेवल पे भी उनको भाषा में व्यक्त करना आना चाहिए. क्योंकि मुझे भी अपने जो स्टूडेंट टीचर्स हैं उनसे जब हम बोलते हैं कि आप इस मैथमेटिक्स को कैसे समझाओगे बच्चे को, तो अगर उनको ये भाषा में परिवर्तित करना नहीं आता है तो उन्हें भी बहुत दिक्कत आती है बच्चों को वही चीजें समझाने में. बस ये मेरा.
I think very well taken. So I was going to say that what Amit has said
that half a page of comprehension you should write. I would say not only write, you must speak about, tell me in 5 minutes, what was the theorem or something in a class. Used to do it in my class, that every week, what is the most important theorem you have listened to me, what I have told you. And you are not going to the board, you are not going to the pen and pencil. You just tell me in words, right? What that theorem is and why do you think it is important? Did I tell you or not? If not, you should say that, sir, you did tell me that is important. So that is math talk, even in higher levels, is very important, right? Because after all, they are going to be teachers somewhere. See, if they don't know how to teach mathematics, how are they going to lecture on mathematics, right? So math talk, as we said, for the NCF, sometimes at 2005 or 15, I don't know when. New one. Oh, at least they have done it in the new one. I thought they would have done it much earlier. That math talk is a very, very important thing. After all, math is a language, right? So if you want to understand the language, you should talk in that language first of all, and then write in that language. That we really sort of encourage. And one joke which is slightly uses some words I want to say. Don't mind if that words offend you. This is a joke which happened, something really happened in America, in a school. A child comes home and is revising his what he learned, and he is saying 2 plus 2, the son of a bitch is 4. His child is saying again and again, right? So everybody understood what I said. 2 plus 2, the son of a bitch is 4. And the mother listens to it and "ये क्या बोल रहा है? हैं? So what are you saying? This is what our ma'am told us today. Really? So बच्चे को कान पकड़ के ले गई कि किताब में क्या पढ़ाया? मैंने तो करवा रही थी मैथ के सम, ये बोल रहा है 2 plus 2, you know what was the sentence? I think most of you know it. 2 plus 2, the sum of which is 4. So the language does play an important part. If in the mother tongue probably, because there the joke was black versus white, so I don't want you to bring that. Uh, so that's okay. So next question, please. Yeah, please see affiliation and then.
So, myself Vikram Singh, I am a school teacher. Like in NCRT, questions in exercises of different level, whereas of the last exercise is miscellaneous exercise of different level. So usually students they find difficulty immediately on the like the transaction after the last exercise and to come to the reach to the miscellaneous, they find difficulty. And so the gap or the fear factor start arising. So, and the second one is the language, as you said, the language. I want to share the one of the, I went for as an observer duty for Parak duty uh, in one of the school, government school, third grade. So what I have observed that the student, they know the mathematics, but they could not understand what is actually being asked in the question. बच्चों को हेल्प करने में अगर किसी को ये बताया जाए कि इसमें ऐड करना, they know that what to add. इसमें ये निकालना है, इसमें ये काउंटिंग करनी, they know that. So it means the language gap. Mathematics to interpret and what to deliver. So somehow is in our like there's a gap basically because of how we deal with the student. This is one of the observation I would say. Second one is assessment level, like what we teach in the class and what we check as an assessment level. हम क्वेश्चन तो पढ़ाते हैं एनसीईआरटी लेवल के क्लासेस में. मोस्ट ऑफ द स्कूल्स आई थिंक दे फॉलो एनसीईआरटी बुक्स. एनसीईआरटी ही क्वेश्चंस कर रहे होते हैं, वही डिस्कस कर रहे होते हैं या उसमें कुछ एक्टिविटीज भी कर रहे होते हैं. वेयर एज इन द असेसमेंट, चाहे वो मंडे टेस्ट आता है या वो टर्म्स के टेस्ट आते हैं, The level is different. So once the child start, they get less marks in their assessment, they think the maths is not their cup of tea. उसमें तो marks कितना ही पढ़ लो आप marks max तो आते ही नहीं. So I think we should change, as in classroom transaction, not only the NCRT we should follow, we should go beyond it. Thank you so much. This is one of this.
You can just hurry up a bit so that everybody,
Thank you so much.
others also get it.
तो मेरा क्वेश्चन सिमिलर क्वेश्चन है
क्या उन्होंने सेशन दिया, कमेंट किया, उनका क्वेश्चन कुछ नहीं था, मेरे को लगा सेशन पे तो आप क्वेश्चन
कमेंट एंड सजेशन मेरा है सर.
हाँ बोलिए.
The gap between school and colleges.
ओके
Yeah, that is mathematics is the language. We have English, Hindi, and other things. We can say that mathematics is the king of king.
आप क्वेश्चन पूछिए क्या है.
मैं क्वेश्चन नहीं सर, क्वेश्चन से पहले फिलोसफी देना.
नहीं फिलोसफी नहीं है, क्वेश्चन पूछिए, टाइम नहीं है फिलोसफी का.
तो मैथ में सर दो लेवल होते हैं, बेसिक लेवल, एडवांस लेवल. तो हम लोग बच्चों को मैथ एडवांस लेवल क्यों पढ़ाने की कोशिश करते हैं? क्लास में जो बच्चे होते हैं, मोर देन 50% आर बिलो लेवल, एंड student who are going for engineering and higher level education, they are less than 50%. तो जब हम स्कूल में पढ़ाते हैं तो हम लोग को बिलो लेवल के बच्चों को देखने के लिए, जो एडवांस लेवल के बच्चे हैं, उनका गैप फुलफिल नहीं हो पाता है. वो जेई के लिए अदर कंपटीशन के लिए पार नहीं पाते. हम लोग अपना लेवल गिराते चले जाते हैं और बेसिक मैथ में सीबीएसई अपना लेवल कम चला जा रहा है. इससे क्या हो रहा है, गैप खत्म हो जा रहा है. इसमें सीबीएसई ने जो एक काम किया है, मुझे थोड़ा सा लगता है कि वी शुड change this in two groups, that basic and advanced. जैसे सीबीएसई ने हायर लेवल पे 11 12 में दो सब्जेक्ट निकाले, बेसिक एंड एडवांस. इफ यू वांट फॉर इंजीनियरिंग, गो फॉर एडवांस मैथ. इफ नॉट, गो फॉर बेसिक मैथ. तो ये चीज हम लोग स्कूल में क्लास 9 से स्टार्ट कर सकते हैं, जिससे सबको मैथ पढ़ने को मिलेगा, एडवांस वालों को एडवांस मिलेगी, बेसिक वालों को बेसिक.
थैंक यू. यस, आई थिंक ओके, फिनिश दैट एंड देन कम विद द प्राइस. सॉरी.
Hello, everyone. I just want to add, I think
नहीं
the
ठीक है.
question I want to add.
So please listen to the question.
I don't have a question. I just want to add on that.
Okay.
That with all these apps, we are talking about so many possibilities which can work best for our students. There is still a ray of hope, and this I realized because I'm working with a school where I'm working with their content development and learning and development cell, and I got a chance to see grade 6 book. I'm a big fan of that, and the way the question has been, framed, the exercises are not conventional. The way the whole with the great thought process, the book has been, rewritten.
Okay.
And I would recommend everyone to go with that. And we are expecting maybe the NCRT will, keep on revising across the grades. But the question is there that I think the onus lies on us that we, the teachers, has to take up the questions in that manner. If we see, the progression of the book, the number pattern, and after that, the order of the chapters has been changed. The integer has been, renamed as the other side of zero, and the geometric construction is now the playing with the construction. So all we need to give a thought, and I still have a hope that with the grades, the new books will come up, and it will slowly and gradually. It would be a time-taking process. It will slowly and gradually. It will change up the mathematical thinking and enhance the mathematics.
That is what the NCRT also thinks of writing that book, that slowly it will change everything. And thank you for appreciating NCRT's efforts. And in 8 minutes, uh, sir, uh, see, you appreciating NCRT and bonus, as you said, is teacher. You see, lot of good material is available. Even before NCRT books came out, there were materials available. Not the prescribed ones, but other available, depending on the teacher, where you want to go. So I think before you go, he has raised the hand. So, no, please, I will take the order. Otherwise, one will go on.
Okay, fine. So, yeah, my name is Vivek Vijay. I teach at IIT Jodhpur. observations and then a question. So basically, we understand that there are two languages. One that I speak in general, and second is mathematics. Mathematics teachers always like symbols. So when I say I when I talk to a lot of mathematics teachers, they say that we do not read the introduction part given in the book. We start with exercise one. So I mean, the language that we are not reading, how comfortable will we be to teach or to talk? So we like symbols, so we prefer to use symbols. That's one reason precisely we use symbols. But one of the great teachers, probably during Professor Rana's time when we were at IIT Bombay, he says, if you are becoming a teacher, just try to think about it. The language that you are speaking to your kids or children, can you speak in the same language to your mother and will she be able to understand if she doesn't know mathematics? So probably I agree with the language that you're talking about. Second observation that I have, I read somewhere that in India the books are written in ABC format. That is abstract before concept. So unfortunately, that's the problem. We start with abstract and go for examples. Like rather than talking to so it should be. I mean, it's a suggestion. And I don't know whether it can be taken in a positive manner. Can we think of writing in CBA manner, concept before the abstract? Then probably the simple problem will get over. And the question that I have to Rajput sir, can we think of minimizing the gap between higher education and school education? There is a I do not know what is happening in schools. At the same time, schools do not know. So, in one of the NEP conferences, we deliberated on that. There is a big gap. School teachers and college professors, they do not sit together. So probably, I mean, this is one of the places that we are discussing, but otherwise it doesn't happen. So are we? Is NCRT thinking like that? Uh, there are many issues which have been raised, but I will like to certainly address two of them. One is if you see the books, I don't know how many have seen the books right from grade 1 to grade 10 for which were written in 2005 and beyond. All books are very good. I don't know because you try to find out numbers, shape, their description, their properties, and certain questions, examples and questions in the book, which are not there. How many of the teachers have appreciated the storybooks of grade 1 to 5 written earlier? Where I'm talking about a journey in grade 4, a journey from Delhi to Bhopal. उस ट्रेन जर्नी में ना नंबर्स भी हैं, लार्ज नंबर्स भी हैं, एडिशन सब्ट्रैक्शन भी है, उसमें शेप्स भी हैं, उसमें अलजेब्रा भी है, सॉरी वो पैटर्न्स भी हैं, उसमें बहुत कुछ है, लेकिन टीचर को दिखाई नहीं दिया ना. टीचर को लगता है कि वो अलग से चैप्टर होना चाहिए था, एक एडिशन का अलग चैप्टर होना चाहिए, मल्टीप्लिकेशन का अलग होना चाहिए, वो एक ही चैप्टर में मैंने क्यों विभिन्न कर दिया, क्योंकि वो अप्रिशिएट ही नहीं कर रहे हैं टीचर, पढ़ाई नहीं दे. 15 साल हो गए मुझे उसको दिए हुए, 2005 में शुरू किया था, 6-7 में बुक्स आ गई थी. अभी भी अगर आप अप्रिशिएट कर रहे हैं, क्लास 6 की बुक क्लास 7 में आ रही है, आप अप्रिशिएट तो करना शुरू करिए. आप टीचिंग, आप देखना कुछ और चाहते हैं बुक में जो हम नहीं लिख रहे हैं. हम चाहते हैं कि आप वो देखिए जो लिखा जा रहा है, जो चाहिए एक्चुअल में मुझे क्लासरूम में, वो दैट इज नॉट हैपनिंग. So obviously we are going to do it. Class 7 book you will get soon in the market. That is almost ready. And class 8 will be sometime in July or August. So maybe June or July. So you will have these new generation books, and from year 2026 onward, we will be having books for grade 9 and 11, and then 27 we will be having books for grade 11 and grade 10 and 12. So these are the books which we are releasing, and I think you all should appreciate these books. You should read. And your question, we used to have when we developed curriculum syllabus, almost everybody sits together. We used to have people from universities also, and we used to put in these all. But problem is what is happening with the entrance examinations. What am I testing in entrance examination for IIT? Content, or should I assess the should I test the aptitude whether this person is capable of becoming engineer or not? I am testing the content which he or she is going to study in that class in maybe first year of IIT or first year of BTech. I am assessing that. I am assessing what is not being taught. We are teaching to the test. That is the major problem. Teaching to the test, not for learning. एग्जाम में क्या आना वो पढ़ाया जा रहा है. लर्निंग के लिए पढ़ा दो तो कैसे भी एग्जाम ले लो, क्या प्रॉब्लम है? एग्जाम तो कैसे भी ले लो अगर लर्निंग अप्रोप्रिएट हो गई है तो। क्या वो किसी एंट्रेंस एग्जामिनेशन के लिए या बोर्ड के लिए हम, तो मुझे लगता है थोड़ा सा उस तरफ सोचने की जरूरत है। We should give emphasis to that. Thank you very much. I think he is very well said that all of our teaching and learning is exam oriented. Even a teacher's capabilities, a अच्छा teacher is evaluated by इसकी क्लास में कितने बच्चे पास हुए, कितनी मेरिट लिस्ट आई, कितने मेरिट होते हैं, आई डोंट नो मापदंड मुझे मालूम नहीं है। It is. So all it goes by that. So a good teacher is evaluated by those things, the performance of a student, right? So that is a bit unfortunate that because teacher is not performing in the exam, okay, it is a student performing. So any other question? Yes. Uh, yeah, please first and after that after you will go. Please.
Thank you for that presentation, all three of you. It was very insightful. My question is for, I'm Chitra. I am from West Bengal. I teach in a school. It's for first generation learners. So I have taught previous year in grade 3, and there were certain, like, so you mentioned that you should, a 13-year-old should be able to teach a 10-year-old student. So I try to do collaborative learning in the classroom, and if some of the students have understood the concept, I try and ask those children to make the same thing understand to others. But somewhere, even me and the students as well, they lack the language of mathematics. And again, it's either we, I mean, it's me and the students who are not able to translate this language. And also, when we talk about the maths problems, we say that we have to, do story sums. We can do it in the regional language, and as much as we do it in the language here, it's Bengali and West Bengal. So the students understand that we can't do the assessments in that language. We have to put English there. So my question is the first, how to translate the language, and the other.
Yeah, all your questions.
Okay, okay.
Yeah, this is the last one, only one question. That's why I'm saying only no two questions, only one. What was the question? Ask them to do back talk. That is the best way. Okay, your question? Mike, Mike.
उपस्थित बुद्धिजीवी वर्ग से मेरा प्रणाम। मैं निरुपमा, प्रोफेसर फ्रॉम कुरुक्षेत्र विश्वविद्यालय कुरुक्षेत्र। मैं अभी जो आदरणीय भाई कह रहे थे उसके बीच में कुछ कहना चाहूंगी कि जो हायर एजुकेशन और स्कूल एजुकेशन के बीच में जो गैप है, पर्टिकुलरली करिकुलम गैप जो मुझे मिला अपने एक्सपीरियंस लेवल पर, मैं कुछ कैलकुलस में पढ़ाती हूँ तो बच्चों को वो नहीं आता, और इसका क्या कारण है? बहुत से गैप का डिस्कशन हो चुका है और बुक वालों की भी कमी आ रही है। पर मुझे जो मैंने पर्सनली फील किया कि अगर हम इम्प्लीमेंटेशन पार्ट को लोअर से अपर की तरफ लेकर जाएं तो कम गैप आएगा। होता क्या है कि कोई भी पॉलिसी का इम्प्लीमेंटेशन सीधा हायर पर भी हो गया, लोअर पर भी हो गया, एनईपी 2020 पूरी हर जगह से फॉलो हो गई। अगर हम यही पहले फाउंडेशन, देन सेकेंडरी, देन आगे हम कॉलेज लेवल पर ऑप्ट करते तो हमारा सिस्टमेटिक वैसा करिकुलम बना हुआ है, तो बीच में बड़ा प्रॉपर्ली डिजाइंड है। एनईपी 2020 में कोई कमी नहीं है।
I think your suggestion is welcome because this is from the policy makers and implementers saying that it should be graded implementation. Right? That is your suggestion. Yeah.
सजेशन इज दैट कि हमें एक स्टेप वाइज
Oh,
इम्प्लीमेंटेशन। सेकंड पार्ट इज कि जब हमारा पॉलिसी इम्प्लीमेंट हो जाता है उसके बाद बोर्ड ऑफ स्टडीज की मीटिंग ना हो, पहले बोर्ड ऑफ
I think those
स्टडीज
are technical administrative matters. Please, that we cannot help it.
नहीं तो इस गैप को कम।
So that you can talk to them afterwards.
हाँ हम कहते हैं ना सिलेबस में है। हाँ यस आई अंडरस्टैंड। जैसे फॉर एग्जांपल जो जो लिमिट की डेफिनेशन है, हाँ जी, वो डेफिनेशन है लेकिन पढ़ाता कोई नहीं है। नहीं दैट्स गुड, मैं कह रही हूँ कि आपको बहुत अच्छा। आई अंडरस्टैंड।
No discussion on this one to one. Please
so much.
I want to
Thank you
thank
so
him
much.
because
I just want to add one.
no, no,
I did.
okay,
Thank you so much.
good. Because there is shortage of time, and so I'm getting indication that okay, yeah. So I just want 1 minute to say and suggestions which have not come up at all to that. I went to a school in Rajasthan, in a village, where that six standard students are teaching third standard students. There is no teacher for them for mathematics or third. Six standard students are teaching. Okay, part of it. So if senior students mentor junior students, that is a very good idea because they know the language, they know the subject and so on. And second is parental pressure. Please don't tell your child, ask your relatives, don't tell your child the mathematics is difficult. Because as soon as the child goes to the first standard, the mother says, "अरे ध्यान रखना गणित बहुत मुश्किल सब्जेक्ट है." Before he goes for a driving school, you are saying बहुत खराब है. So don't do that. Thank you very much for participating and hope that gap will be reduced sooner or later. Thank you.
Please give a big round of applause for each and every panelist for this enlightening session. गणित केवल संख्याओं से नहीं बल्कि उन संख्याओं के पीछे छुपे सिद्धांतों और विचारों से जीवित रहता है. So, ladies and gentlemen, we are now starting the keynote talk 4 on the fascinating topic visual and combinatorial thinking in teaching and learning mathematics. And this session will shed light on how visual and combinatorial approaches can transform the way we teach and learn math. As we continue with our exciting program, it's my great honor to introduce to you the individual who will be guiding us through this session. Please join me in welcoming our esteemed session chair, Dr. Janaki Ghosh, with a huge round of applause. Uh, so we come to the last session of the conference, and as we say that the last session I'm sure is going to be really grand. It is my honor and pleasure to, though he doesn't need an introduction, but to introduce the next speaker, the keynote talk by Dr. Shailesh Shirali on visual and combinatorial thinking and teaching and learning mathematics. So, Dr. Shirali serves as the head of the teacher education program of the KFI, the Krishnamurti Foundation, and he is currently based at the Valley School, KFI, in Bangalore. He has been with schools of the KFI since the early 1980s and is the trustee of KFI. Early, he served as the director of Shahidri School and the principal of Rishi Valley School. He has been in the field of mathematics education for many decades and has a particular interest in ancient Indian mathematics. He has written, as we all know, many books for high school students, in fact, for various levels. He has also a deep interest in nurturing and facilitating inquiry into fundamental issues among teachers and students at the high school level. It is really an honor, Dr. Shirali, to have you. And in fact, I would say that in all my decades of that I have known him, at various conferences and workshops that we've interacted, his talks have always have real gems that you can learn from. So we look forward to this without much ado. And thank you, please.
Thank you very much, Janaki, and thank you very much to the MTA for inviting me for this occasion. So I'd like to take this occasion now to just introduce this theme. I think this is something which comes up in the NEP also. They've talked about how to bring in computational thinking and combinatorial thinking into school mathematics teaching. And I feel it is something that is quite possible. So in the time available, I'm going to try to introduce this thing. So first of all, what exactly is this? So basically, combinatorial thinking means exploiting the structure of a problem without getting completely involved with algebraic manipulation. Basically, you're trying to understand the heart of a problem. Problems are, what actually is there underneath the problem. So it's getting the essence of the structure. So you don't use a huge amount of machinery of algebra and so on. It's a much more subtle thing. And visual proofs, I think we all know what visual proofs are. We see something, why something is true. The picture which is drawn so beautifully, it illustrates some relationship perfectly. Without need for any words, you can see why the relationship is true. So there's a great appeal to the imagination. And I think we need to work, teachers need to work at developing this ability in children. I think we all have this ability, but it needs to be developed because we may have it only in some kind of a nascent form. So both of these illustrate the power and elegance of simple ideas. And I think that's something which needs to be emphasized at the school mathematics level. In fact, visual thinking may well be the way that our brains actually process information and concepts. Because actually when we receive information and the brain puts it away into a memory, it may not be doing it quite in the way that we sketch it out here. It is much more a visual kind of a representation. So today's talk is part expository. I'm going to see how much is possible given the time. But it's also part experimental and suggestive. And I'm going to just sort of toss out a few ideas which we could try at the school level. So I'm going to just present some examples. These are purely experimental. Some of these I've myself. So for example, let's look at this square array of. By the way, some of the examples that I'm going to show are well known, but some are perhaps not so well known, some are new. So I'm going to start with something which is very well known, just to show you what we are talking about. So what do we see here? We just see a square array of dots. And can we, in our mind's eye, look for spot different shapes, different relationships within that array? That's the basic question. And so there's a lot of appeal to imagination. So one very well-known thing, well, you just see n squared dots. So here's something which is very well-known. That's quite a well-known thing. We group the dots this way. So the same n squared dots are grouped in the same shaped form. So basically, what kind of a mathematical relationship do we see? Well, we see this. 1 is equal to 1 squared, 1 plus 3 is equal to 2 squared, 1 plus 3 plus 5, and so on, and you get this relationship. The sum of the first n odd numbers is equal to n squared. That's quite well known. But is that the only way you can, only possibility of exploiting this basic structure? I'll show you that there are a few more. For example, let's try to group it this way. Now it's exactly the same thing. You've got n squared numbers, n squared dots, which have been now grouped in these squares. So right in the middle, there's one dot. In the square immediately surrounding it, how many dots are there? There are 8. In the next one, the next square surrounding that one, red square, you'll notice there are 16. So you'll notice 1 is just 1 squared. 1 plus 8 is equal to 3 squared. 1 plus 8 plus 16 is 5 squared. So we find a new relationship out here, which we have got just by grouping the same n squared dots in different ways. So 1 plus 8, so it's 1 is sort of stands separate. After that, the successive multiples of 8, which you're adding together. So we have just got a certain algebraic relationship, but only got it from the way the dots are grouped. Here's another one, a tilted square. So I've just shown it in a diamond form out here, which we've grouped in these various diamond-shaped structures. So what do we see? I claim that the middle, you've got a 1 dot in the center. then you have 4 dots surrounding it, then you have 8 dots surrounding that one, so on. So basically what you got is 1 plus 4 plus 8 all the way up to 4n. But that's one way of grouping the dots. Is there some other way? Well, you can group it like this with a lot of horizontal lines. And the top one, the red one, is basically 1 plus 3 plus 5, right? And the bottom one is 1 plus 3 plus 5 plus 7. So you'll notice that the way it has happened is that you have two sets of sums. One is the first few odd numbers, and the second one is another set of odd numbers, but a slight one more. So you've got 1 plus 3, etc., plus 5 with some n terms, and is 1 plus 3 plus 5 and 4 plus with one more term, n plus 1. But that's n squared plus n plus 1 whole square. So here we go another set relation which we have found purely visually. We have not proved it by the usual symbolic method. So 1 plus the successive multiples of 4, adding n squared plus n plus 1 whole square. And this you can actually verify this. So once you've got it, it will be an interesting exercise to show that it is actually true. You can the usual summation of an arithmetic progression and so on. Here's another one. Here it's a triangular array of dots. So what do we see? So there's 1 plus 2 plus 3 and so on. So basically got half of n times n plus 1 dots. It's the sum of the first n numbers. Now, is this another interesting way of grouping these half n plus 1 down? Well, see, you can group it in different ways. What if we try to group it like this? So the outer shell, you can say, two sides of the triangle. Then we go inside another side, keep going like that. So in this situation, the inner one is a single dot. Then the next layer has got 5 dots. The layer after that has got 9 dots, so on. And there are 8 terms in this. And so you've got an interesting relationship out here. 1 plus 5 plus 9 all the way up to 4k, they're all numbers of the form 4k minus 3. That adds up to the 2k minus 1 triangular number. So you've got some interesting relationship there. So I'm going to jump over the next few because we are a bit short of time. So similarly, you can try the same thing with even numbers, and you end up getting another such relationship out here. So I'd like to emphasize that this is a very open-ended thing. It's not something that I would like to teach as a topic. The question really is, when you give a configuration to a child and you throw it open to him or her, what kind of different ways do they observe in that configuration? What kind of things do they see? Because each such way is going to be the source of a new relationship. This is an example. And I'm quite sure that by using different configurations, different kinds of relationships can be found. So I'm going to show you some other kinds of combinatorial thinking examples. So some few we may jump. So let's take this very simple one, n plus 1 whole squared. Now the next few examples are not visual, but more combinatorial. So let's the basic simplest identity. So what shall we do? We take the set of numbers from 1 to n plus 1, and you consider all possible pairs of numbers from this. So how many such pairs are there? N plus 1 whole squared. Because I can anything to n plus 1, similarly for this. Now you can say, let's subdivide the pairs according to how many ones they have. If there are no ones at all, that means you're choosing the numbers only from the numbers 1 up to n. So there are n squared such pairs. If there's one in it, then the choice is only for the other one, the other entry. And there are n of those, but that one can be in either of the two positions. So there are 2n of them. And of course, if there are ones, then you get one such pair. So that you get this identity, n plus 1 whole squared is equal to n squared And similarly, you can, if you instead of looking at it as pairs but subsets of two, which means the order doesn't matter, you end up getting this relationship. N plus 1 choose 2 is equal to n choose 2 plus. So you get, so by different ways of grouping, you're going to get different relationships. Here's another very interesting problem. M plus n choose 2 is equal to m choose 2 plus n choose 2 plus mn. In fact, there's a beautiful game depend which I can show you. Maybe it will be nice to show it here. Just maybe at the end of this session. I'll just take 2 minutes. So how do we prove this? Well, we take two sets A and B, which are disjoint, A having m elements and B having n elements. And S is their union, A union B. So S has m plus n elements. Now you ask, how many ways can you choose two elements from S? Well, obviously it is m plus n choose 2 because that's the definition of 2 square. Now, those two elements can either be both from A. If they're both from A, then there are m choose 2 possibilities. Or they can be both from B, that gives you n choose 2 possibilities. Or you can have one each from A and B, and that gives you mn possibilities. So you so adding up everything, you get that relationship. So now this is well known. Perhaps we'll skip this. Yeah, let's look at some binomial identity. What I'd like, if I hope we can get there, I want to show you, in fact, how to get combinatorially the sum of the squares of the first n numbers, which is a very interesting problem. Normally, 1 squared plus 2 squared up to n squared have only induction. We use induction to prove it. I'm going to show you how to get that sum in a combinatorial way, and similarly for a sum of the first n cubes. So this is fairly well known. We have count of an element set in two different ways. I don't. It's quite well known. We don't have to go into it. Similarly, this is quite well known that n choose r is equal to n choose n minus. So what is the combinatorial way of saying it? Not by algebra. Well, choosing r elements from an n element set is the same as choosing n minus r elements and then rejecting those. So obviously the two are going to be the same. So this, in the context of the discussion that just took place before this, it shows this is a very language dependent reasoning. There's a lot of language which comes in here. You're not using so much algebra, it's visual, and it is also language. So it's a very interesting way of studying and looking at mathematics. So this is another well-known, very fundamental relationship about the combinatorial coefficients. Slightly less, it's well-known, but slightly less obvious why it is true. And the way you can do it is by looking at all the ways of selecting R elements from an N element set, and then you just look at one particular element, let's say X. You just isolate one X. Either it has been chosen or it has not been chosen. If you decide in advance that it is going to be chosen, then you only have to choose R minus 1 elements from the remaining N minus 1 elements. So that gives you the first term in the right hand side. Or you have decided that it is not going to be chosen, so then it's like you have just put that aside, so that gives you the second one. Similarly, for this very beautiful summation, uh, I will not go into the details of this, but it comes out asking this question: in how many ways can you select a committee from n given persons, given that the committee must have a chairperson? So if you just do this in two different ways, first of all, you can see again here there does seem to be some a little bit of symbolic thinking. You can either decide to fix the committee size first, then select that committee, and after that choose a chairperson from within that committee, whoever you've selected. That's one way of doing it. Or the other way of doing it is select a chairperson first. So you got hold of the chairperson first, and then the remaining persons you select them. So just do it in two different ways, and you get an identity. It's quite remarkable that just by switching, swapping the two things, you end up getting this very simple identity. And you can you can extend this logic. You can say instead of a chairperson, what if there's a vice chairperson or a vice captain or whatever? Get another such identity. So you can extend. So I won't go into. Now let's look at this summation. Is there a way um, of finding the sum from 1 to n, which we normally get? How is this done in the level? How will we get the answer to this? Yes, the well-known one is the way Gauss associated with Gauss of switching the order and writing it as n plus n plus 1, n minus 1, and so on. So that's one way. Is there any other way of finding the answer? Ah, so that's also that's very visual. Yeah, take with when another that which on the side and you get a rectangle out of it. So there are different ways, the visual way, the flipping the sums way, that's Gauss associated with Gauss. So you combinatorial. So you consider the set of numbers from 1 up to n plus 1. And you ask this question, in how many ways can we select two elements from S? So by definition, the number of ways is n plus 1 choose 2. Obviously, you're selecting 2 from n plus 1, so to n plus 1 choose 2. But now let's look at it in a slightly different. You can say, let's group the pairs according to the larger number in the pair. So if the larger number is n plus 1, then you fix the largest number. It's always already n plus 1. So how many possibilities are there for the other number in the pair? Well, there's n elements altogether, so n different. If the larger number is n, then the lesser number can be everything less than n, which means there are n minus 1 possibilities. If the larger number is n minus 1, you get n minus 2 different possibilities. So you put everything together, you get 1 plus 2 plus 3 altogether up to n different possibilities. But in the previous way, we got it as n plus 1 choose 2. So you've got this answer, that 1 plus 2 plus 3 up to n is equal to n plus 1 choose 2. So that's a different way of expressing that sum. Normally we express it just as n times n plus 1 upon 2. It also happens to be equal to n plus 1 choose 2. It's a combinatorial coefficient, which sometimes students may not notice. So here's another such summation which you can get. If instead you consider 3-element subset, not 2-element, last time we considered 2-element subset, that is pair, you consider 3-element subsets, you get another such relationship. 2 choose 2 plus 3 choose 2 and so on up to n choose 2 is equal to n plus 1 choose 3. And you can guess how it could have been true. I think we don't know that yet. You can guess how it can be true. That is, you think of the 3 elements and group everything together according to the largest number in those 3. So you think that largest number is n plus 1. Then you have to select 2 elements from everything which is less than n plus 1. So that corresponds to n choose 2, the last term on the left hand. If the largest number is n, then the remaining 2 numbers are everything from a set to n minus 1. You end up getting n minus 1 and so on. So the left hand side enumerates all those possibilities divided according to the largest number in that triple. So obviously that is going to be the same as n plus 1 choose 3, which is the one which comes on the right hand side. Okay. So same way you can consider, you can get an identity using the 4-element. And all these turn out to be instances of what is called the artistic theorem, which I think in the Pascal triangle, if you draw the Pascal triangle like this, 1, 1, 1, and 2, You can start from any point on the right side, right, go down, and then a single line like that. So I've marked out in yellow 1, 3, 6, 15, and then 1. So it's shaped like this. So you'll find that the sum of all the ones which have been marked yellow is always going to be the number which is marked green. So that's referred to as the statistic. It's essentially the previous result expressed in the same way. Okay, before I come to sums of squares, I'd like to show you an interesting, just as a diversion, because we've had a lot of long sessions. So let me show you something which is not, it was not planned. So I'll show it to you here since it is not there. It's quite a surprising result, which let me come to the left and show it. So I'll describe the problem to you. You can, it can be sometimes done with matchsticks, or it can be just with a number. So you start with any number. So let's just say 10. And I ask you to split it into two numbers in any way you want. So you just tell me, can you tell me some two numbers? I mean, whole numbers. So 3 and 7. So in the right hand side, we write the product of those numbers. Then again, split each of these. So let's say we split 7 in any which way you want. Can you just decide? 3 and 4. So 3 times 4, we write 12. Then we split 3, of course, there's only one way of splitting it as 2 and 1. So 2 times 1 is 2. This is also just 2 and 1. Again, so this 2 can only be split as 1 and 1. So just split 1. Each time you write the product. Similarly, 1 and 1, you write. So what is left here? Now 4 is left. We can do it as 2 and 2 or 3 and 1. Let's try 2 and 2 this time. So you keep going with this till everything becomes 1. So you get 1 and then another. It finally ends like this. And now you add up all these numbers. Each time you do it, you will get a different sequence of numbers. But you just watch what happens. So what do we get? 21 and 12 is 33, 45. You'll find that no matter which sequence of you follow, you'll always get the same sum. You can try it out on your own. And what is that number 45? What is so mysterious about that number? That's what is so beautiful about it. In fact, that number is equal to 10 choose 2. And I would like you to try it out. The numbers, you can. It's a very nice party trick. You can use matchsticks and actually do the multiplication. And of course, it's very surprising that every time you do it, no matter what the numbers you get, you always seem to get the same answer. And it turns out that it is the triangular number corresponding to the initial. Uh, yeah, yeah, we'll just back again. So now this is the question: how will we? What might be a good way of finding the sum of the squares of the first n numbers? Now, what would, if you wanted to do this combinatorially, how would you do it? That means you have to find somehow a problem in which, on the one hand, you can find these different squared quantities give you the count. They count something. And then you do the same counting in some different way. So that is the only way you can get a formula for this. That is, you're doing the same thing in two different ways. So let's do it like this. I'm going to define a set which I call T subscript n, which consists of triples ABC like this. So ABC are integers between 1 and n plus 1. And A should be strictly less than C, B should be strictly less than C. But A and B can be same, or there's nothing specified between A and B. Okay? So there's no order relation between A and B. We permit A is equal. So for example, T1 and T2 I've shown out here. So what is T1? T1 is between 1 and 2. So everything is either 1 or 2. And the first number should be less than the last one. Second number also should be last. So there's only one possibility. It can only be 1, 1. So there's only one possibility for T1. For T2, you will find all those possibilities. There are five possibilities which come out. So if the last number is 3, then 1, 1, 3, 1, 2, 3, 2, 1, 3, 2. And then the last number is 2, only 1, 1. So this is the definition of that. So the question is, how many triples are there in this set? That's the how many triples are there in T. So I'm going to look for two different expressions, and you will find a very nice answer comes. So first of all, so let's look at the first way. So remember that A is equal to B is permitted. So I claim, let me come here and show you. If you fix the value of C, then A can take any value between 1 and C minus 1, because it has to be less than. B also can be any value up to C minus 1. Oh, ignore the part. So it can be strictly less than C, so C minus 1 possibilities. And since both of them have no connection between them, you get C minus 1 multiplied by C minus 1, which is C minus 1 squared. And C itself can take all values from 2 up to n plus 1. So that means the number of triples is just 1 squared plus 2 squared up to n squared, right? Or if C is n plus 1, that is the maximum possible value, you get n squared different possibilities. If C is n, you'll get n minus 1 squared possibility. If C is and so on. So you get this sum. Now the only challenge is to find another way of computing the same sum. So I'm going to subdivide the triples into two different categories. There are only two types of them. One in which there is no repetition of numbers. A, B, C are all distinct numbers. The other type is of this type. It is the first two numbers are the same. A, C. So let's count them separately. And we have to just keep in mind that A is always less than C, B is less. So now with that restriction, it becomes quite easy. So I claim the first type in which the all different means they it's three different numbers from numbers from 1 to n plus 1. You're just selecting three numbers. How many ways can you select three numbers from n plus 1 different numbers? It will be n plus 1, 2, 3. But now the first two can be arranged in two different ways. Either you put the smallest first and then the middle one in the middle, or you put the smallest in the middle and the other one first. So that's why multiplied. And how many are there of this type? C. AAC means you're only selecting two different things, A and C. The fact that there are two A's repeated means that two numbers being selected, A and C, plus 1 plus 2. So that's it, you're done. We've got a formula for the sum from 1 squared up to n squared. It's a very different looking formula for the sum of the first n squared, very different from what you normally find. And you can put it in another form which still looks. Uh, remember that these, if you apply the basic recurrence relation of the combinatorial coefficients, that n plus 1 choose C added to n plus 1 choose 2 gives you n plus 2 choose 3, which means that you have this relationship because in the previous one, there was 2 times n plus 1 choose 3 plus n plus 1 choose 2. So you break up the 2 and take 1 out. So 2 of the terms combined to give the left side sum. So this is a very surprising result. Sum of the first n squares is simply equal to n plus 2 choose 3, n plus 1 choose 3. And you can test it out. For example, try type with n equal to 4. If you add up the first 4 squares, you get 30, 1, 4, 9, 16. And on the right side, you can add 6 choose 3 plus 5 choose 2, which is 20, and 10 also gives you 30. So this is a different answer to that summation of the squares. And just to show you this, you can actually do the algebraic simplification. N plus 2 choose 3 plus n plus 1 choose 3. Standard way of doing it, you'll end up getting that answer. Of course, this is using algebra. It's not a combinatorial. So, what time is it, Janaki? Yeah, yeah. So, I won't spend too much time on the sum of cubes. I thought I would include it here because the same idea works for the sum of cubes. You can find a formula for the sum of those cubes, 1 cube up to n cube, just by finding a suitable combinatorial problem. And just like it's just an extension of the previous idea. So we look at this one, the set of quadruples. Instead of triples, we look at quadruples, A, B, C, D. 1 less than or equal to A, B, C, D, less than or equal to n plus 1. And all of them less than D. This should always be the largest number. And if you just do it very carefully, I won't go through it. You'll do it very carefully, you'll find that the number of quadruples is just this. Just like last time we got the sum of the first n squares, this time you'll find you that end up getting the first n cubes. And now it's a matter of figuring out how to find the same sum in some different way, combinatorial. Well, the same strategy works. We divide it into two different categories. One in which they are distinct. And what are how many other types are there? Apart from this, you can have, because the only choices or only variation possible is for ABC. Remember, D has to be the largest. So among ABC, maybe 2 are repeated or all 3 are repeated. So if 2 are repeated, it will be something like this type. A, B, T. So 2 things which are same. If you could commute, permutations are possible. And this A, 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 D. So it's for this counting A3. So the first one is just going to be n plus 1 choose 4 because you're just choosing 4 different numbers. And the first 3 can be computed in 3 factorial ways, so 6 ways. So 6 times n plus 1 choose 4. And this one turns out also to be, is a 6 here also. It's equal to n plus 1 choose 3. Why? Why? So what is it? You're now choosing 3 different numbers, A, B, D. So n plus 1 choose 3. And then those, if you look at the permutations of that, well, 3 permutations because there's a repetition. But you also, hmm? Yeah, but you have a choice of which one to repeat, whether it is a smaller number which is repeated or the large. So that's right. So it's not directly 6, but it comes as 3 times 2. So you get 6 in the end. And this is the easiest one. Number of permutations of this is n plus 1 choose 2. So adding everything, you get a formula. So the sum of the first n cubes is 6 times n plus 1 choose 4 plus 6 times n plus 1 choose 3 plus n plus 1 choose 2. And this is a completely different formula from the usual formula. And now that you got this idea, that you can do exactly the same for higher, you can just discover the formula on your own. You can try it for first class, fifth class. You just have to figure out that set, that underlying combinatorial definition. Okay, this exercise we can leave. Here's an interesting problem which perhaps is not often seen at the school level. See, if you look at the binomial theorem, you have n plus x to the n is equal to this. And if you put x equal to negative 1 minus 1, then 1 plus x is 0. So that means, so you get this result. So n choose 0 minus n choose 1 by putting x equal to minus 1, then plus n choose 2 minus, all of it adds up to 0. What that means is that if you just separate out the even and odd terms, that means n choose 0 plus n choose 2 plus n and so on, equals n choose 1 plus n choose 3 and so on. Now, what is the left-hand side counting? It's counting all the subsets which have even number of elements, right? 0, 2, 4, and so on. On the right side, you're getting all the subsets which have odd number of elements, 1, 3, 5, and so on. Which means that this statement is basically saying that there are as many even subsets as odd subsets. Now, it's an interesting question. Is there some direct way of showing that there are as many even cardinality subsets as odd cardinality subsets? And so this is one way of showing. So this way, this kind of an argument is completely algebraic. It's not combinatorial. So you may want to look for a combinatorial way of doing it. And one way of doing it is this. So we choose any fixed element in the set and then partition the sets like this. You can say either they contain X or they don't contain X. And either they are of odd cardinality or even cardinality. So you get a 4 or 2 kind of classification. So subsets in this collection have odd cardinality and the contain X. Subsets here have even cardinality and contain X. Subsets here have odd cardinality and don't contain X. Here they have even cardinality and don't contain X. And you want to show if you added all these cardinalities, it's equal to all these cardinalities. And there's a nice way of showing it. You can say that these two, A and B, put into one correspondence. And the way it is, each subset here. What does it mean? It's odd cardinality and it contains it. We'll just remove that element X from it. If you remove that element X, what you've got left over will now have even cardinality because you've removed one element. And X means you have landed it in this place. And the reverse can be also true. If you take any subset here, it has got even cardinality, it doesn't contain X. Put in that X, you end up here. So these two are of the same cardinality. And similarly, these two are of the same cardinality. So this shows this just by matching the elements against each other, you manage to show the result. Incidentally, I should add here that what we are using in this combinatorial reasoning is one-to-one correspondence in many, many different ways. It's about endless repetitions of one-to-one correspondence, and one-to-one correspondence is perhaps the most primitive and ancient form of counting. Even before we had formalized the number system. We don't know when human beings first formalized, identified some numbers and called them 1, 2, 3. But almost certainly, even in very primitive times, one-to-one correspondence would have been learned. Because you can match if you have some flock of sheep, for example, you may be able to count it by doing a one-to-one correspondence with some pebbles which you keep in your pocket. And you can make out if one sheep less at the end of the day. Or anyway, so now finally I come to Fibonacci numbers, which is a very beautiful topic. And this is something which perhaps some of you have already seen because it's been talked about a lot late. Manju, tree right now, connected with EP and the writing of the textbook, and associated with him is, he often talks about this. So you may have seen this. It's well talked about. I'll show you something, some interesting uh, aspects of it. So usually the Fibonacci numbers are defined arithmetically. So you have the sequence 0, 1, 2, etc. And you see some of the numbers. That's an arithmetic definition. It's not a combinatorial definition. So I'm going to start by not talking about the Fibonacci numbers at all. But a slightly different problem, which is equally surprising. So I'm going to define something called a composition of positive integers. So composition of a number is defined this way. It's a string of positive integers which have the sum is that particular number. So for example, these are the compositions of 3. So what are the different strings you can have which add up to 3? So they can have it just 3 itself, or 1, or 2. 1 and 2 are different strings, just like A, B, and B are not the same. And then there's one more string, 1, 1, 1. So you have these 4 strings which are all compositions of 3. So here's a very interesting problem. Can we count number of each particular integer? So let A of n be the number of compositions of n, which means A of 3 is 4. We just listed the 4 compositions of 3 there. So the question is find a formula for A of n. Is it n plus 1? No, you'll find the answer is more surprising than n plus 1. Can you guess, anyone? Anyone would like to guess what the number of compositions of n is? Try it with 5. What are the compositions of 5? Let's try it before I go to the next slide. Let's try to get the compositions of 5. Or 4. Compositions of 4. Anyone would like to guess what the answer is? This is an example of a problem which can be done right at the middle school or even the primary school level, because all you're doing is adding numbers. Seven. Okay, let's try. So the next, in fact, all the answers are given in the next slide. So the take away the excitement. So let's look at the compositions of 1. So there's only one composition of 1. What are the compositions of 2? 2 and 1, 1. So that's the composition. We already got the compositions of 3, 4 of them. Well, we have 8 compositions of 4. 4, 3, 1, 1, 3, 2, 2, 2, 1, 1, 1, 2, 1, 1, 1, 2, and then 1, 1, 1, 1. You'll find 8 of them. And then 5, 4, 1, 1, 4, 3, 2, 2, 3, 3, 1, 1, 1, 3, 1, 1, 1, 2, then 2, 2, 1, 2, 1, 2, and so on. You add them up to 16 of them. So we have an unmistakable pattern here, a pattern which I describe to you. Why are we getting this beautiful this doubling sequence? In fact, we seem to be finding that A of n is just equal to 2 to the power of n minus 1. So why should it be true? This is a very this is a question which lies at the heart of mathematics. When you observe a pattern and you get irritated and upset with it, you can't understand why there should be a pattern at all, and you're struggling trying to find an explanation for it. Probably this is how mathematics gets created. When you really throw yourself against the pattern and try to find out why should it be true. Well, different ways of proving it, which we are not going to discuss. There's a very beautiful proof which is part combinatorial and part algebraic, uses kind of recursive logic in which you refer the n, the string with n, which adds up to n in terms of the strings which add up to n minus 1 and so on. And there's another way also. We want, I don't have time for that. What I'm going to do is look at a related problem and show you how it is connected. It has some echoes in what happened in ancient India. Hmm. So suppose now I don't, I put a certain restriction on what you can use in the composition. See, previously there was no restriction at all. You could use all the numbers. Now I'm going to allow you to use only ones and twos. So since, in fact, when I was writing out this thing, I found that there's no name for such a thing. So I just called it a 1-2 composition. You can only use the numbers 1 and 2. Hmm? So the question really is, how many of compositions of that kind are there whose n string? How many one which add up to a particular number? So here are the composition 1-2 compositions of 3. You can have 1, comma 1, so 3 composition 4. What are they? You can only use ones and twos. So you can have 2, 2. You can have 1, 1, 2, 1, 2, 1, 2, 1, and 1, 1, 1, 1. So how many are there? 5. So if you start, you can ask the same question: how many compositions are there of a particular number? So let's call it C of n. So C3 is 3. And the problem becomes find a formula for C of n. And this problem, it turns out, is what we studied in ancient India. Hmm? They, because they were very interested in ancient India, they didn't put it like this in this pure abstract mathematical way. It arose in the context of certain questions of grammar. So this is, they were in ancient India, they were very, very particular when they wrote the Sanskrit shlokas that meter exactly came out right. Everything had to match. When you wrote a poem, the meter of the first line and the second, everything had to match exactly. So they were very, very observant of the syllables that they were using in the word to see that the length of the whole line matches is not lost. So that's what is known as property. So it was studied by these famous grammarians like Pingala and so on. And they did divided the syllables into two types. They were either short, so I just called it S, or long, called it L. The original Sanskrit words are Guru and Guru. Guru is the heavy or long syllable, and Guru is the light syllable. So it's the same as it's basically like one and the pure abstract mathematical part of it is that it's just 1 and 2. But it is written. So there's only, if you consider how many words are there with just one beat, well, just how many words are there with length 2 beat? You can have L and SS. So it turns out to be exactly the same problem as what we just described. And this table gives you the actual result. So there's just one word with length 1, 2 words with length 3 with length 3, 5 with length 4, 8 with length 5, and 13 with length 6. And these numbers had been discovered in this. So essentially, they are the Fibonacci numbers, but discovered in a very different way from the way Fibonacci discovered. So this is the table of values of Cn. And it turns out that C's are just a displaced Fibonacci sequence. In fact, if you actually compare it with the Fibonacci numbers, it turns out that C of n is the n plus 1 Fibonacci number. So because one number has been left out in the beginning. Now, how do we prove this? Obviously, in mathematics, you don't stop at just observing a pattern. We have to somehow show that why it is true, and that's not difficult. So it, you do it by looking at the last syllable of a word. Consider all words whose length is n bits, where n is more than 2. Each word ends either in S or in L. So let's just delete that last syllable and see what is left over. If the deleted letter is S, obviously what is left over has got length n minus 1. If the deleted letter is L, then the modified word has length n minus 2. And you can take all possible words with length n minus 1, just put in an S at the end, and you'll get something with length n. Or you take all possible words with length n minus 2 and just put an L at the end, you'll get something with length n. So that immediately tells you that the number of possibilities with length n is going to be the sum of the previous two numbers. So you can see the basic Fibonacci property in there. So for example, for n equal to 5, this chart shows it. The ones in red are the ones ending in S. The ones in blue are the ones ending in L. You can see these are which are Fibonacci numbers. So you immediately find that this sequence follows the Fibonacci recurrence, and a little bit more argument is needed to show that you actually get the Fibonacci number. For that, you have to say that it starts with a pair of consecutive Fibonacci numbers, and is the Fibonacci recurrence. Every number is a Fibonacci number. So this is a very beautiful uh, illustration of how the same set of numbers, the same kind of property can arise in very different parts of the world in a very different way. It's happened many times in mathematics. And you can have variations on this theme, and I'll just show you another such variation. Suppose I see last time I put this restriction that the numbers used could be only ones or twos. I put a new restriction. You can only use odd positive numbers. That means 1, 3, 5, 7. You can't use any other number. Surprisingly, even this situation ends up giving you the Fibonacci numbers. Just one. So how many ways can you make just one? Well, only one. How many ways can you make two? Only one way, because you can only use the number one. What about three? You can use, remember, two is not allowed now. You can use only odd numbers. So it's 1, 1, 1 or 3. So there are two possibilities. What about 3? You can have 1, 1, 1, 1, 1, 3. Sorry, I've counted, oh, sorry, U4 is 3. So, so you find if you just observe carefully, you'll get find that UN is the nth Fibonacci. Now I'll show you the same thing in a geometric variation, which perhaps children may like to do. So we'll take this shape, which is a 2 by 1 rectangle, and you want to make a 2 by n rectangle using n dominoes. For example, n equal to 4, you take 4 dominoes and arrange them in different ways to make this shape. There are many ways of arranging them. So how many? So I'm going to use the red color to denote a vertical domino and the green color to denote a horizontal domino. So these are the different ways of using 4 dominoes to make this shape. So you'll find that there are 5 ways of doing it. So I'm not given the proof here, but this is just another hidden way of counting Fibonacci number. And there's yet another way of expressing it here, another geometric variation involving dominoes, in which you're making it's not a 2 by n, but just a single strip. You're finding ways of stacking together either dominoes or unit squares, you put this together to make the whole shape. So then you get the same Fibonacci number. So what this shows you is that the potentialities of using counting to do this are really many. You get a vast number of possibilities. So I won't go into all that. And maybe this is not the time to go into a proof of a Fibonacci identity using this. Since lunch is coming up, I won't go into the proof of this. But you'll find that a proof which would normally be done using induction, or you can use something called Binet's formula for Fibonacci. You can prove it just directly using this idea. It's a very, if you try it out, it's a very amazingly simple proof. You can prove, all you have to do is subdivide all the tilings of m plus n into two types. One is those in which there is a natural fracture line which comes at the position m, and the other is in which position m is, there is no break out there, but it is covered by a domino, which means it is either like this, there's a, so there's n and there's a fracture out there, or it is like this. And if you just count both possibilities, you that that without any algebra and just put some information that similar to the Fibonacci numbers, there is also what are called the Lucas number, in which you start with 2 comma 1 rather than 1 and you get 2, 1, 4, 11, and so on. So those numbers are very similar to the Fibonacci numbers. They are well, they also can be defined in this kind of way, and it turns out that you have to look at circular strips instead of something which is just linear. And so on. So there's a lot to discuss in this. So I'm going to end out here. Just I've just asked a question here. What is the value of studying all this? Does it have any significance? I feel personally that such study surely helps to nurture visual and computational thinking. Why? Because I think the potential of thinking along these lines is there in all of us. It doesn't require some very special algebraic ability. People are very good at algebra, very good at complicated of integrals and so on. This kind of thinking is not of that type at all. It's a different kind of thinking in which you're looking at how things sort of combine together. It's more subtle in a way, and yet I feel that the seed of it is there in all of us. And also there's beauty in it. That's what I've ended with this, because I think mathematical beauty is also a part of the greater aspect of beauty, and I think it's a very important experience for children to see, to develop a sense of beauty, a sense of aesthetic, something which is beyond description. So I'll say thank you. Stop.
For taking us on that amazing visual combinatorial feat. I think every slide had a well ideas which we can explore. And if you could share your slides, I think we'll be putting it up so people can try these problems. Already shared. So, any questions? Quick questions from the audience?
school level and higher school level. So it doesn't have to go into very subtle and complicated aspects. At the simpler level, different ways of arranging things to see relation, look at find relationships.
Counting problems which we were discussing in earlier workshops also that there needs to be more emphasis on that in the earlier years, which is not there. Everything suddenly moves to calculus, and so this way of looking at these identities through the visual pattern and counting them, it's an exercise. Actually, it's a low threshold exercise, but can also lead to the further exploration. So they are low threshold and high ceiling in that sense. So in generally in mathematical induction, I think students are not taking interest as far as generally in mathematical induction, the students are not taking interest actually. But if we are showing such kind of patterns, so they take more interest in it.
Are there any textbooks for schools? Because most of the ideas we're going to see later, or maybe in Olympiad training. Surely at the school level, there are not too many. One book, yes, last time. The book called Proofs That Really Count. A person called Master Benjamin. He has got, that's a bit higher than this. It has very nice examples. But I think we have to, for the school level, we perhaps have to create our own materials. It's an opportunity for us to create materials that are appropriate for the school level. At the moment, I think there are very few. Not that there's nothing. I think, for example, this basic recurrence relation of the combinatorial papers. It is seen at the. But for example, the idea of one-to-one correspondence, just associating one thing with something else. Yeah. Discrete mathematics is never taught as such at any level. It's just picked up. That's all. But so there is a need to have some structured courses for school level, maybe workshops or something. Because even at BSc level, probably BA, there's hardly any offering of discrete mathematics as such, which is very important. Yeah. And it's not only important, it's amenable, as he has shown. Thank you. Thank you, sir.
Okay, I think with this, we will end the talk. Can we please give him a big round of applause? Thank you very much. Okay, so now we were planning to go for lunch and then come back for the closing session. But if it is all right with everyone, we can have the closing now.
Then we would like to go for a photograph to the auditorium, a group photograph, and then move for lunch. And from lunch, you can sort of depart. Okay. All right. So shall we go ahead? Uh, so, uh, Sunit, before Suniti and I would like to read out share our closing remarks. Both of us have things to say about the conference. It has been an amazing journey organizing this conference together. But just wanted if one or two participants could just share their overall feedback about what you felt about the conference. A very candid, frank feedback. Just quickly, to short, nothing brief, nothing very elaborate. Any participant would like to come up and just share your feedback or overall experience, what it has been.
Uh, Thank you very much for giving us opportunity of uh, discussing with various stakeholders. And special thanks because I feel like platforms where school teachers and higher education teachers, that's one of the main points that I have. When we talk, we don't know what is happening in uh, other way also. So thank you very much for giving this chance. And I was telling to Sunilji also, when we invited them to Jodhpur, thought Jodhpur food is the best. Then after having dinner over here, uh, I told him that no, I was wrong at that. So yeah, and giving this kind of opportunity is really learning graphs from Professor Anna and puzzles from him and whatnot. I mean, everything was available in the plate that we had. So coming again back to the school days, we learned not this way, but yeah, a lot of groups in different ways, all these things. But uh, giving this kind of flavor is really needed. I think, I mean, will be every state organizes such kind of workshop that will really help the teachers. So I have learned a lot, especially when I next time go to school, I'll have a lot of things in my bucket. Share. बहुत अच्छा लगा बहुत सारे लोगों से बात करके we had everything from Vedic mathematics to the contemporary mathematics what and the way these things were discussed I think I mean हम लोगों को बहुत सारी चीजें सीखने को भी मिली बहुत सारी and one thing that we have done after last time workshop that we had at time conference that we had at IIT Jodhpur all eminent people we developed this math lab that you could see outside heaven. That was one of our experiment that we did at IIT Jodhpur. Some of our students they helped us, and then now they opened a company, and we could install in more than 200 schools. So that is really helping. I believe that there are three ways of learning. One is the abstract way. Some people learn in that way. We learned in that way. Second is the visualization way, and third is like learning by doing. So that kind of things we have created. I mean, these kind of platforms give us feedback. So last time, a lot of people gave us feedback, and we could redesign that. This time also, we got a lot of feedback. So thank you very much for that, and thank you very much sir, for inviting us over. Thank you. Any other artist?
It was indeed a very enriching session and, of course, inspiring too. And, we all, I don't know, I would tell from my own experience when I was told to attend this 3 day long workshop, the first apprehension that was into my mind was Friday, okay, Saturday and Sunday, getting into some conference. I don't know what kind of takeaway that I'm going to come back home with, but yes, it actually tossed the coin. It was very enriching, very a lot of learning that has happened here, meeting each and everyone here, learning from each other and also from all the dignitaries, whatever workshops we attended, today's panel session and everything, had a good takeaway for us. Discussing the problems that we come across every day in teaching learning process has also, given a solution to many of us. And of course, the best thing that I liked about this entire 3 day long workshop was that we could interact with each other, discussing the problems, also getting a solution, and then learning many new things which there were few which we already were aware of, and there were few which came on to us as a surprise. So it was definitely a beautiful session conducted by all. I knew Janaki ma'am, Sangeeta ma'am earlier, Hani Gandhi ma'am who was there yesterday with us. We had attended a lot of GeoGebra sessions and a few more sessions with Janaki ma'am as well earlier. But then knowing a few other people like Sunil sir yesterday in that the Harpan's session, it was an amazing session and it was great learning for all of us. Thank you so much. Keep organizing such sessions again, and we'll definitely be like to part of it.
Uh, is a chance to give a making a math community. Not only that we will have conferences only. You can make 4, 5 people make math community, talk to each other, get some chances to discuss. Uh, the purpose of this conference is to get together. The math community, if they talk with each other, you don't have time. Actually. You are so much engaged. All of us are so much engaged that we don't want to build our own capital. Whatever we are doing in a routine, we are keep on doing that. So, as Mr. Sadish, as you have seen how much he has and he's still working on getting some new things, sharing with and every one of you can do. It's not that only some people can do. All of we can do. The only thing required is the time and the patience. So, improve yourself, make change in yourself, keep on changing. Every time we are learning and think of doing something different. Uh, uh, in the session of gaps, one question, once I shared in one of teacher training program, I asked teacher, suppose one student has solved one question of simple interest by, suppose the question was 1,000 rupees percent rate and 10 years. So what is the value? But instead of 10, no, 1,000, he wrote 10,000. So the answer was different. So what was the marks given to him? The question was, what was the purpose? The asking question of simple interest was that he should know how to calculate the simple interest. So he should know the way. So that is not for zero. He knows how to calculate all the. He knows the result. Only the one mistake he has made that he has written the statement wrong. Someone. But our purpose was to ask him simple. So see, he knows or not. So that's something maths that either zero or full that also we have to look into. So make it also a procedure and according to what he has done. Uh, so uh, yes, you want to share.
As I told you earlier, also I am not a mathematician. And before joining this conference, I thought of myself that I am a genius in mathematics. But after joining this first conference of mathematics, I am nowhere in the line of mathematics, maybe somewhere in minus infinity. Thanks for that.
Actually, everyone has a lot of things. Everyone, and each time we learn. Whenever we meet people, see new things, learn new things, and we add on. So keep on adding on whatever you have. Keep on adding. So this is what any other participant want to say. Okay. So yes. Please.
Am I am I audible? Yes, okay. So it is my honor and pleasure to give to sort of summarize and give the closing remarks for the conference. So we have come to the end of the MTA Northern Region Conference after 2.5 days of intense engagement with various aspects of earth education. We hope you've had an enriching experience. So I just like to very briefly, I think because this is important because we've been through a lot in the last 2.5 days, but now it's important to consolidate our ideas. And I hope this will also feed into a report of the conference. So, firstly, I would like to thank our four keynote speakers for their very, very illuminating talks. So, starting with Professor Shobha Bagai in her talk on innovative approaches to mathematics education on project-based learning and classroom narrative. She illustrated the benefits of this mode of learning through several examples of initiatives taken up by her in the Cluster Innovation Center. So, by sharing classroom stories and reflective experiences, she demonstrated how project based learning can emphasize real world applications and critical problem solving. The second keynote by Professor Ramanujan on problems posing for the mathematics classroom was indeed an eye opener. I think we'll all agree. He began with what really constitutes mathematics learning, and that problem solving is not akin to solving end of chapter exercises. Through examples, he illustrated how teachers can pose meaningful problems to their students, and these need not be from outside the syllabus, they can be well within the syllabus, and they can be structured in that way so that they spell out mathematical thinking. He described characteristics of good problems, which gives us a lot of food for thought, problems that help to sustain the interest of learners, and problems which have some pedagogic purpose. He further explained what entails problem solving for questioning by connecting with the big ideas of mathematics, for symbol pushing, and for making connections. The third keynote by Professor Fozia, which you of course saw today, was really amazing. It actually revealed that mathematics is a subject to be celebrated. I think we all know that, but somehow we never acknowledge it perhaps when we are teaching. And if we celebrate it ourselves, then our students will also find reasons to celebrate. So she shared her experience of organizing math festivals with school children, and we saw some of amazing pictures, examples that she shared. And it showed us that how the students were so deeply engaged in those tasks, and this can truly go a long way in alleviating math phobia. The last keynote, of course, by Dr. Shirani. He illustrated that visual and combinatorial thinking both are important pathways for learning mathematics. And we as teachers need to give thought to how we can incorporate it in our teaching. Truly, you emphasize the power of elegance of simple ideas, presented us with so many interesting examples of patterns. For example, looking at arrays of dots in different ways. It took us truly on a journey of combinatorial reasoning, looking at known identities in different ways. So we even saw the Fibonacci variety numbers. All these things can be brought into the classroom. Then we had very two vibrant panel discussions. In the first one yesterday on professional development, mathematics design and implementation, led by Professor Ambar Habib, and the four panelists, Professor Haneet Gandhi, Professor Jyoti Sharma, Dr. Reddy, and Dr. Ruchi Kumar, all shared important and critical insights on the theme. Dr. Reddy recommended that teachers should access the use of expository articles for their own professional growth. He shared many interesting examples and resources. Professor Jyoti Sharma focused on what professional development truly means for a mathematics teacher. Professor Hanif Gandhi shared important pedagogy for big classrooms, and Dr. Ruchi shared many aspects of her rich experience of working with teachers
and teacher educators from many countries. The audience interaction thereafter led to the understanding that there is a pressing need for structured and yet flexible continuing professional development programs for teachers that impact for math teachers, and their impact needs to be assessed regularly, not do the workshops and attend and just forget about them, but some more is needed to see how they are impacting the class. Further, we need more professional bodies like MTA to provide forums for teachers and build teacher communities who organize and engage in their own professional development. I think the key learning from this session was that we simply cannot wait for somebody to structure programs for us. We have to be responsible for our own professional development. In the second panel today on bridging gaps in mathematics learning, chaired by Professor India Rana, there were three panelists: Professor Anup Rajput, Professor Amit Kurshesh, and Ms. Geetika. Ms. Geetika highlighted gaps at the school level. She emphasized that math phobia is a predominant reason for these gaps in learning. And also, she pointed to a very important fact that the nature of mathematics itself is like a skyscraper. So, one concept builds on another. So, if the gaps are created at a certain lower level, then obviously their impact shows at a higher level. Uh, Also, the societal pressures due to preparation for entrance exams and coaching was pointed out. Professor Anup Rajput emphasized two very important things: gaps that arise, that is, content related gaps and pedagogical related gaps. We need to really keep these in mind when we are talking in the teaching our students. Amit ji pointed to gaps at various levels, and he focused on a very important thing, that is the source of these gaps. That there are curricular gaps, gaps caused by societal pressures. And then he rightly pointed out that who is the society, who are they creating these pressures? Parents, teachers, and then there is the market. He also pointed to a very important fact that the language of mathematics is different from the language that we speak in. But to develop a facility for the language of mathematics, we also need children need to be emphasized their actual language. Uh, Interesting thing you pointed out is that there are good gaps and there are bad gaps. And I think we need to understand which are also these good gaps and how we can show these in our teaching. Uh, Also, the need for creating aha moments in mathematics. Okay, so after this, the paper presentation sessions addressed the different themes of the conference, and it was heartening to see very interesting examples uh, of classroom practices, uh, math activities, and research initiatives taken up by participants. There were 15 presentations in all, which were held in two sets of parallel sessions, and 11 poster presentations, which were also very, very interesting topics on varied and many interesting topics. The workshops engaged everyone absolutely. People, I think, despite it being very late, I think everybody was engaged. Rita, of course, thank you for that brilliant session uh, on GeoGebra. So I know that she's really the icon of GeoGebra. So there's not much I can add to that. But it is amazing how she has, as a teacher leader, I would like to just say this. I'm maybe digressing a little from the report. We need more like her, more people like her, people who grow the trajectory that the teacher takes, the identity that we build as a mathematics teacher needs to be strengthened more, and we need more people like her. Who each of us has different. We try out different things in our classrooms, but we need to sustain that, and we need to continue in that effort. And she has really contributed greatly to this area. Thank you for doing that session for us in this conference. Professor Ambar Habib's session was also an amazing session, providing an initial exposure to the use of the software R and for simulation, in which he showed some very interesting simulations of probability. And Mathematica was outstanding. I mean, looking at all those areas that Mandel said, and how simple command and mathematical can lead to such beautiful fractal patterns. Sunil Bajaj took the participants for an exploration of puzzles, illustrating how these can be incorporated in the classroom. The main takeaway was that now that NEP is talking about incorporating games and puzzles, I think this workshop had a very important element. Professor Rana's workshop was really thought-provoking because it provided a first-hand experience of functional thinking and graphical reasoning. I do not know why we do not incorporate graphical reasoning much earlier in our curriculum. I think the world has talked about it, there are research studies on this. And some of the ideas that, we looked at graphs and created stories which those graphs might represent. We also did the reverse. Given a situation, we represented it graphically. So all these things, workshops gave us a lot of, I would not like to talk about my own workshop, but the fact that computational thinking and mathematical thinking can be integrated to meaningful activities is something that I am also learning and exploring. As we draw this enriching conference to a close, we extend our deepest gratitude to the keynote speakers, panelists, workshop participants, session pairs, and presenters for making this conference so vibrant and engaging for all of us. Thank you for sharing your insights, experiences, and thought-provoking discussions with us. Your contributions have not only deepened our understanding of mathematics education, but have also inspired new pathways for teaching, learning, and for research. We appreciate the time and effort that you have devoted to this gathering. The dialogues and ideas exchanged here will continue to resonate with us, and I'm sure will trickle into our classrooms. I would like to thank all the members of the program committee, without whom this conference, this program could not have taken place. Local organizing committee, of course, were phenomenal. My heartfelt thanks are due to Professor Geeta Venkatraman, President MTA, for always providing important and relevant ideas. Unfortunately, she fell a little unwell, so she could not attend the second and third days of the conference. Uh, I would like to thank Dr. Shweta Naik. Do you all know Shweta? Yes. Uh, Even in absentia, like she has been the driving force of the conference, not only managing the financial aspects and communications with regard, I think every member or participant has received an email from her. She manages it also effectively that it also seems so seamless. I'd like to thank her very much. I'd like to thank from the program committee, Amber, for conducting the workshop, for chairing the panel discussion on teacher professional development, and for providing many insightful suggestions during the planning of the conference. Thanks to Ruchi for chairing the two paper presentation sessions and also for being a panelist. I would like to express my deep gratitude to Sri Sunil Bajaj for proposing this collaboration between MT and SCRT. I mean, one, of course, when you have to do such a big event, you need somebody to come up and offer their. So under his leadership, the entire organizing team of SCRT have done a truly phenomenal job, right from planning and logistics to ensuring a seamless experience for all of us. Your hard work has indeed been the backbone of this conference. In this context, I would of course like to mention the names of all the members, but I would specifically like to mention the name of Dr. Shivani Kaushik, who has been with me for several weeks before the conference. I was like here. Please, please stand up. Your dedication to the conference is truly laudable. Now, if you please give me one moment. I do, because I do want to call out the names of all the faculty members. Sir, may I call out the name of the theatre? Okay. So there's Dr. Shivani, Dr. R.K. Ponia, is he here? Please. Dr. Suman Sharma. Okay. Dr. Sheenu Dahiya, Dr. Manoj Kaushik. They're not here? Oh, okay. Dr. Manoj Sharma.
Dr. Madhu. Uh, okay. Okay, right. Rupam Jha, ma'am. Dr. Sunita Chaudhary. Sri Kuldeep Birwal. Yes. And Dr. Ashwini Kumar. So all the faculty members, then I would like to also the faculty members of CSD, Dr. Rakesh Kumar Soren, Dr. Reena Devi. They were all part of the planning committee, Miss Anju and Miss Saroj. Then from among the diet staff, we have Shri Anil Kumar Yadav, Mukesh Ji, Shri Mukesh, and technical support, Mr. Sabir and Mr. Dev. That was a very important aspect of this conference. Um, so who do I now talk about next? Who are the people I think who truly need a standing ovation? Yes. So it's really amazing because, when I do in my institution, I always tell my students that you have to be involved in the organizing of these things because that's a real learning experience. I hope you agree with me, right? Okay, so let me call out the names of all these amazing people who were there with us. Did you notice that they were standing throughout the talk? And even in the other sessions, they were always there. They were not sitting down. Yes, I'm calling on him. So Ronak Joshi, uh, if you are here, please stand up and or just wave. Gopal Kumar, Chandan, Swapnal, Aditya. Oh, they are nice. Saurabh, Nikita, Vinita, Divya. Divya is there? Okay. Kanishka, Chadarika Singh. You are speaking? Okay. Niyati, the amazing anchors of these sessions. Deepika, Bhavna, Shiv Prakash Shukla, Vijay Bhardwaj, and Raman Bhardwaj. So we truly, their enthusiasm, dedication, tireless efforts behind the screens have ensured that everything ran smoothly, from assisting with logistics, guiding participants to managing sessions and technical support. And last but not the least, the warm hospitality provided by SCRT in and arrangements in our stay arrangements. Thank you so much for all that. Thank you, sir. Now I request you to please share. No, I think you should say a few words. Yes, please, please. If I may have forgotten, I apologize.
First of all, this camera team that NCERT has provided us, they have worked wonderfully. And from CIT, Professor Amrendra Bera, Joint Director, trusted him and he sent the team. And all the 3 days, they worked a lot. So, on behalf of Director Shri Samvartat Singh and Director Siyaste, Dr. Rishi Goyal, I want to thank, first of all the participants. So, first of all, please give a big applause to presenter. Please stand up. A presenter if they are here. Paper presenters, please. Sit down. Next, poster presenters. Yes. And then the participant. Because of you, the conference happened. If you were not here, then conference could not be happened. So it is only because of the presenters, participant, and the poster presenters. Because of you, this conference held at SCERT. You
applied, you came here and participated very well. So, and then because of you, you came, you registered, then all the experts we invited presented wonderfully, talked with you, discussed with you a lot. So I thank to all the experts, chairpersons for the time this given to this conference. Uh, Also, I want to thank uh, the people, our group four people, those who are working all the time in managing all those things. So they also worked hard, keeping tears here and there, cleaning all the toilets and all those things. Uh, so in the end, I also want to thank our school education department who allowed us to conduct this conference. We already in our annual program proposed six conferences. So one of this conference by our request, MTA agreed and they requested us, and we were also waiting for to hold this conference. So we sit together and organize this. So thank you all for giving us this opportunity to conduct this conference. This is our first national conference as a SCRT. I am here for the last 20 years, but this is the first national conference SCRT has conducted. And also, I am thankful to Siaste team. Actually, they worked a lot. Because of them, this conference can be held so comfortably. And in the end, uh, we will be together. We will work for mathematics to make it more interesting and challenging. So build your community, talk to each other, learn from each other, share with each other. But whenever you know something, share with all. That's what the message we should keep on. So now I think we will go for a group photograph. Yeah.
My apologies, but I just thought that I wanted to clarify, and this Shweta also asked me to clarify that for the TA, so everyone will get a mail from MTA, right? That MTA is 18 email that's saying that please share your tickets and all that. So just share soft copies, and they will tell you how. I mean, they will respond to your card.